server. My group is my name, my username. Is your group your username?
Probably.
It's really
Probably is the
weird.
default.
Is it?
It may just be default.
Yeah.
Till they group us into something?
Yeah. So it's probably just, global read is
So we should show them Fiji with a group file, just so that they understand what a group looks like for real, even though
There's
it's not
future
true.
Dr. Hunt.
You and Ariel today, are you covering permissions? And if so, how much of permissions?
I'm going to cover very briefly, but
That sounds good. I think he should do the in-depth, and you should just do there are permissions, and we will
I was
talk
gonna
about how
do
to
it
deal with them
about
tomorrow.
this, Just be like,
Perfect.
you can see permissions. We'll talk about this later.
That sounds great. Put it on day 3. Sounds good.
Has Ariel shown up yet? So your job is to sit there and take notes about what we need to cover tomorrow, like spasms.
Oh, no.
So I might have to teach his section.
Okay.
What?
Are you okay to do that?
Oh yeah.
Ariel said he's having spasms. There he did. He made it. Good.
I was gonna say if I do that,
I
then
gotta
just go
tell him
print out
something funny.
Ariel, I have something funny to tell you. My son was watching the videos last night, and one
And
of your
first
videos starts with,
oh, wait.
hello, but the video before it is really
really
low.
quiet.
So he had cranked the volume up. So then he went to your video, and it goes, hello, and he about lost his shirt. He came out of his skin. And,
Yeah, the Vim tutorial is right before it. It's really quiet. I might need to adjust the volume. It was just funny because he almost fell over. He's like, oh my gosh.
I'm glad I could provide that experience.
How excellent.
Good morning.
Feeling all right?
Good morning.
I do, so I
I can do your section if you need to.
No, it's all good.
You sure?
I start with the capstone every day, so I'll start that. But do you want to check your laptop real quick?
Yeah, I was gonna say, let me check my laptop.
That seems like a great
And
idea.
then,
Okay, I can't one-handed do this.
no, you can't. And it's probably not a good idea to do it one-handed.
do you happen to know what the workshop is?
Do you need an adapter?
Yes.
I have
I was
that
gonna
one.
say, I was gonna run up and grab
It's
that
everything
actually.
to everything, so you'd be fine.
And we know it works because it was just working with this one, so,
Probably just leave this plugged into the HDMI.
yeah.
Yeah. Yeah, if I can ever get this in, there we go.
Yeah, the typical one she orders isn't everything to everything, and then I was like, I still have a super old monitor, and she's like, then we're gonna get you this one, because it goes to everything.
Is there a charger?
Charger?
Oh, no.
There are plugs here
Yeah, that is also.
and
powered
there.
right there.
It was working for a very brief moment.
Mine did that yesterday, and then I had to close and open again, and it worked. I don't know what that is.
Or unplug it.
I was gonna say, plug it back in maybe.
Try turning it off.
I did that twice, and then I just closed the computer and opened it again, and
Oh,
The,
I see.
I don't know why that worked, but it worked, so you know.
That's it.
Well, a brief flash. What's that doing? I don't know why it keeps asking me for that. Let's try going to guest.
See, I feel like the server day isn't gonna take the full time, but I know it absolutely is.
Oh, it
Yeah,
will.
absolutely.
Because one of the things that John had them do was, here's the SBASH cheat sheet, build one that does a FOSQC run, and just dropped it on them, and it took all
Because
day.
suddenly they realized the things they were supposed to be learning on Monday actually matter.
Yeah, that's always the
That's
shock,
why-
right?
that's-
It's
that's
just like,
the
wait, I was
point
supposed to be
where
paying
the train hits them
attention?
tomorrow. Shoot, because it's like, okay, now take the Vim that you learned on Monday, and the Unix you learned on Tuesday,
And the
write a
SBASH you
script
just
that we just
learned.
and boom, you're done.
Yeah, I was gonna say, we're going over Vim in the exact same detail we went over yesterday for that reason.
Yes, this is a repeat. Yes, we are doing it on purpose. You must know how to do this tomorrow, because you have to do it on your own.
Yeah.
Get straight to FOSQC.
Yeah. We do. We just have them run it. We don't have them look at it. We literally just have them
Oh,
run
there it is. Well, no, it's gone again.
I like,
Let's try
who's helping me tomorrow?
different port.
it. Me. I'm your assistant. What do you want me to do?
I have an SBASH script to just run like a
Oh, hold on.
echo to a file.
Mirror
or just
displays.
like the demo.
Okay.
Just had to press the
Do
touch
that
bar
and
maybe.
then,
Oh, no.
FOSQC.
Extend
Drop them
desktop.
on it. Go for it. There's your sheet.
Yeah.
You
We'll
should
do
be able to
like-
read this and figure it out.
We'll do like the tail end of whatever Unix doesn't get covered today. So like your permissions.
Do you want to use the slideshow? Oh, you already texted me. I'll find out afterwards.
I can look at the slideshow.
I think we do permissions in it, I'm pretty sure. The other thing we don't cover today, I don't think, is man. Do we cover man?
We cover man.
Okay, good.
Yeah, that.
Do you cover
permissions,
dash help as your
Yeah,
alternate background?
yeah. I mean, half the bash commands don't actually have a help, they just have an error flag.
Yeah.
But it works.
It's the joy of non-standard standards.
Yeah.
The thing that confuses them the most tomorrow is error and output files. I swear, every
know.
year they are just
Yeah, I
so
know.
confused.
So, I wonder, is explaining standard error standard out?
I don't know.
So she did to me.
can
The
run
first
exam
time
another
I
one
was
of these and
confused
see
about
if
it,
that
she
works.
explained
Oh, do we have
standard error, standard
VGA?
out,
We can
and
just
that
see if it's
helped.
this HDMI cable.
Helped a ton to understand.
Oh, well.
This whole
I
get
think maybe like the tricky thing is that
Huh? Oh, yeah, 1 second. I just wanted to see if I can get this working for more than 5 seconds.
just that I think we at least
Let me try restart.
No,
Yeah, it just flips on and then flips back off. So,
it's gotta be a permissions problem. Is it a slideshow? Because you can always move it to mine.
I mean, I was just gonna do, basically 99% of what we're doing is just turn.
Oh, well, you can always do it on mine if you can't get that to work.
Like, I think. Oh, yours is working fine. All right.
So it's not the cable.
It couldn't be the cable, because I
Yeah,
was
I was
using
gonna
mine a
say,
minute
we can
ago.
also try the built-in adapter here.
I couldn't get the built-in one to work, which is why I switched to mine.
Ariel actually starts us off, so.
Okay, well, I'm gonna start the
could run up-
capstone before everything.
Yeah, I could also just, I'm gonna maybe.
Run up and see if yours
Do
does
you
it.
want me to grab the VGA adapter from the classroom or from the,
So I was just gonna grab one from the room next to us, because it's got VGA and HDMI. But
okay, because we do have a lab VGA adapter.
That's
yeah,
good to know.
I guess we could do that. I don't know. I don't know why VGA would work and not HDMI.
I can try it.
Yeah.
Your adapter? Okay, so let's start with the
I'm
capstone.
gonna go grab that and the laser pointer.
And we can take a break between you and Ariel and try and mess with yours. Oh, please do. It'll only take very, very short. This is always just a brief intro. Okay, everybody, good morning. Welcome to day 2. Today we will be learning what is sometimes called Unix is actually Linux, but they're so similar people don't tend to specify between the two. We're going to be going through the capstone first, we're going to do a Vim walkthrough, and then we're going to do a bunch of... Oh, that's weird. It was just doing it. You know, I wonder... I was going to say, we did not check the other side of it. Just a second. Because I was not having a problem, and then... Did that help at all? No? I'm gonna unplug it and replug it in. Find this. It's not gonna work at all right now, so unplug. There we go. Now unplug back in.
Okay. You've got,
Good. Maybe it's just this end of the HDMI.
we did pull on it.
Yep. Okay, so Vim, no, it's still not?
I just die when it goes to presentation mode.
Maybe that's it. Maybe we just don't put it in presentation mode. Something about presentation mode or mirrors? I won't worry about presentation mode then.
Is this your old laptop?
No, I'm renewing it. Which part? Okay, looks like we can't do presenter mode, but that's okay.
So,
We'll just make it really big. Okay. Do Vim walkthrough and then some Unix and Linux. What is Unix and Linux and why are we using Linux? It's still not up there? Is that it? No, we do a restart of the system.
you can't.
Nope, that didn't do it. It might be the connector. Hey, Ariel, I have an idea. I was gonna say, this is on the internet, why don't I just, I was just gonna say, we'll just give you the link, and then I can just do it from your computer, because you're gonna be next anyway. Do you have Keybase open?
Can you come this
My
way?
computer can't do PBs for some reason.
Oh, I'll email it to you then.
Okay. Let's do that. Oh wait, I'm gonna unplug this, make sure I don't have anything incriminating open.
Go right ahead. Always a good idea. Could be that,
Could be.
because if,
Oh, caps lock is on.
Today's Tuesday, so I should be in the building today, but I don't think she's here this morning.
okay.
Okay, that's it. Yeah, just some flag tag stuff. All right.
So I'm emailing you the link,
Sounds like a plan.
and it just says capstone.
I don't want people to see my email, so I'm a little paranoid.
That's totally fine.
I don't have internet. That's a problem. On the bright side, these issues are sorted now. Won't be a problem later.
So the thing you'll learn is that bioinformatics people have the worst tech problems at conferences. It's always them who can't get it up there.
Not for lack of trying.
That's true.
Okay.
Is it not there yet?
Not there yet.
Okay. Did I send it to your Gmail or is your?
When did you just?
I can't
He
open
can't open
Keybase on my
Keybase.
computer. It's a little old. I'm sorry.
Make sure it got sent to the right email.
I did 2562. Oh, there it is.
Okay, just took it a second. It was, floating through the interwebs. There you go.
Relatable. All right.
You need access? You shouldn't. I thought I opened it to everybody.
Yeah, I
Changed
have
anyone's
the.
link.
It's trying to sign in as my other Gmail account.
Got it.
Yeah, so I gotta tell it to use.
The right Gmail.
Colorado.
Yeah.
Okay, now let's try this. Okay. Can we do presenter mode?
You gonna test your lab?
Present. Yeah, that worked. Okay, so talked about that. So why Linux? A lot of you are probably used to Mac or Windows, and they each have their own pros and cons. Windows is very pretty and easy for new users who have never touched it before. Macs can do almost anything as long as it's on the App Store. Linux can really do anything. However, it is totally written by free source people. So it is not the most user-friendly. It is not the easiest to find out how to do things. However, you can literally do anything you want. And that's what's most important when you're doing analysis, is being able to do whatever you want. So I've got two things that I found funny about Linux and Unix that will sort of give you the concepts. Can I make this thing big?
Yeah, but you're gonna have to load.
Hello, I'm a Mac.
And I'm a PC.
Hey, PC, check out my cool photo library application.
Neato. Hey, have you seen what I can do with this snazzy Excel macro?
It's pretty tight. Timing while I do my desktop search.
Very speedy.
Pretty cool, huh?
Look what I can do with this multiple desktop thing now.
Oh, that's nice.
Hey fellas,
Hey there, Linux.
what are you looking at?
Nothing.
Are you running Linux?
Linux.
Looks like you're running Linux.
No.
You sure?
No.
Yeah, maybe. Yes, I'm running Linux.
Not me.
It's okay, Mac. We're all friends here.
I couldn't help myself.
Feels good to admit it.
So it turns out that even though you guys think you're not running Linux, quite a bit of what's under the hood on your computer is Linux.
Everything OS 10 after is built on a BSD kernel. So it is Linux.
Hi, I'm Matt.
And I'm a PC.
And it's still running.
Hey, Mac, aren't Macs?
There's a bunch of Macs versus PC, by the way. Okay, so Unix, Linux, you can do whatever you want. It is not
So
easy
it
to
may
learn,
really
but
be
once
the-
you are able to learn it, you can control everything. The problem is, it is unlikely you will be able to remember the command you need when you need it. To this day, I still Google half of what I'm doing in Unix. So it's okay to Google it. We're going to learn about a command called man today. It's okay to use the man page. It's actually preferred. You're not going to be expected to know how to do it. So there's this great cartoon about Unix and the command tar, and it says that the bomb will blow up if you cannot input your correct command without Googling it. And he goes, sorry guys. The point is, it's okay, every time you go to do something on Bash or Unix, you're gonna have to look it up, and that's normal. Okay, so again, remember your red and green stickies? If you do not have them, we will pass them around again. We will be asking you to show us green when you're done with something, red when you need help. And with that, I will let Ariel take over.
To test this. And see how it's running.
Alrighty, hello friends. I'm here to teach y'all some basic stuff about moving and navigating through the command line. So the first thing that you should do before we get started is get comfortable. So there's a worksheet for day 2. You guys should take that out. So we're going to follow along through that. And that way you won't get lost. Or if you do, it'll be easy for me to find you. Then once you have that out, give you all a second to take it out.
That would be on dna.colorado.edu under the short workshop where you saw the videos.
Thank you, Mary. I would have definitely forgotten. What's the name of the what? This would be day 2, so okay, let me look it up. Yeah. This is going to be Introduction to Unix Linux. Is that going to be it? Let me see. Yeah, it's probably going to be the Linux walkthrough. Let's see if that's it.
Yep, that is. Linux walkthrough is what it is.
Amazing. All right, great. You guys all have it? Awesome.
I'm going to be passing these around if you guys need them.
Okay. So with all the coding stuff, you're going to be looking at a bunch of words, right? So obviously you're going to want to make yourself comfortable at home in your computer, some might say. So make your windows large and change your font sizes. We have instructions in here on how to do that. So for Macs in your terminal, it's just going to be Command plus, so like that. In addition to the Command button, click the plus, and that'll make your terminal larger. And then for Windows, if you're on MOBA Xterm, we have a set of instructions to follow, but I'll walk you through that real quick. So we're going to go to Session, SSH in the top left, and then there you're going to type in your remote host. So this is going to be my username, added2562 at.
Are you showing us how you do it on a Windows machine using MobaGo Xterm?
Yeah,
Which means that if you're on a terminal or on Ubuntu,
Command plus plus. In
it will
addition,
make your screen bigger.
yeah.
You're trying to get your screen all set up. You're going to be using that screen all day long. You want it nice and comfy.
Make it easy to read. So, yeah, you're going to use this number as your server again. And then from there, you're going to hit terminal settings, and terminal font settings should be there. And you can increase your size, make stuff bold, etc. Okay. And then if you're on MOBA Xterm, once you have your font size changed, you can just hit OK, and that'll save.
Help with that red sticky notes. I have masks for our helpers up near my desk. You guys need them.
Okay.
Go ahead and start your terminal so we're going to hear what you're saying.
Okay, cool, I can do that. Well, I was going to show them how to sign in too if they need to on MOBA Xterm.
I don't think most people are really expert, most of them are Ubuntu.
Oh,
If you're signed in, you give us a big green sticky note on the back of the thing. You are signed in, give us a green sticky note on the back of the computer. The AWS
thought we had to use Nova Xterm. I could switch to Ubuntu. That'll make things easier.
Most people are using Ubuntu. We have a couple who have to use Nova because we get Ubuntu links otherwise.
Oh, okay. I'll switch to Ubuntu then.
You should be logged into the instance. If not, let us help you get it. Some people are. So it's got to be one of some people.
Okay. Should I move on? Should I move on or are we just vibing?
We're just getting everyone set up.
Oh, okay, so it'll take a bit.
Yeah.
Okay, cool, then I should fine. What's that? I 100% did. Thanks, Lynn.
They were supposed to do an update this morning to make it bigger. I wonder if it's not done yet. Okay, it looks like nobody's on, so
Should we?
let's just do it on their terminals, because you're not,
Yeah,
you can
just
do a lot of
CDing
the same stuff on
Yeah.
the same terminal.
Okay.
So
Sounds.
some of it will be the same, but when we start copying BIOTA18 terminal, we can't do that yet. We'll wait till we get the terminal back up.
Okay, cool. So we're gonna obviously, for now, skip the logging in section, so this is not gonna work for anyone. So from there, we can just skip into.
Oh,
Is
never
it?
mind, Matt just emailed me, they changed the number of the cluster.
Okay.
Yep,
Okay.
this is why you never get attached to IP addresses, because they change.
Jeffrey Bezos.
As soon as you detach your IP address, it's gone forever.
It was that one and then advanced to that one.
Okay, that's your new number.
Yep, I'm on.
And not down because.
This is why we didn't give you that number permanently in the documents, because it changes. And you give me a green sticky note if you are now on.
A chorus of sticky notes moving through the class. What happened?
It's 252.
Ah,
That's normal.
setting the example. This is troubleshooting we're doing right now.
And the word is yes, so every time you get on a new server number, it will always ask you that question.
Okay, great. Are we all on there? More or less?
Green sticky notes tell them you're on, I think so.
Seems like it. Okay.
Your red sticky note will come around and help you.
I think when we get started, it seems like we had a lot of these big sticky notes.
Yeah, we're mostly green, go ahead.
Yeah. Okay.
We'll help the people who are reds.
So, we've been talking a lot about the different things you can do on command line, and all of these things you obviously are going to do with commands, which basically just tell your computer where you're going next. So one of the commands that we would be using a lot today is cd. That stands for change directory. I'm sure all of you could have guessed that. And with any command, where's the mic? Here we go. With any command, you can actually put in options known as flags to change what command you're putting in. So for example, on cd, you can actually ask your terminal for help. So you can do --, help, and the flag I would be using here is the help flag. And once you hit enter, you'll get a bunch of different options that you can use. Should I take that mic?
What does CD stand for?
Change directory. Yeah, you guys probably didn't hear it, sorry. I'm gonna put this on my body somewhere. Oh, is it this way? Oh, wait. Hello, okay. Is it on?
Can you hear him?
I don't know, it's back there better than here, they've got a weird system. Can you guys hear? Okay.
Hello? Is
The
it
lights work from up here, they come down, so the back end of the room here's the lights, where the front doesn't.
All right, let's try this mic thing again. 'Cause I don't think it's going. Did it speak from my diaphragm?
The podium mic was working, I was trying to get you better.
I'll speak up here.
You can move it.
Okay, great. Sorry. Okay, so anyone who missed that, the cd command stands for change directory. And on any command that you put into your terminal, you can use flags. In this case, I use the help flag, which, if you're ever lost on what you're doing, can provide for you the different options that you can use for your different commands.
And Taylor asked, how do you know you're on the server?
That's a great question, Taylor. And so if you see up here, when I'm on my desktop, I have the server part of the address being my desktop. And now that I'm on the AWS, the server part of my address is now the number we've been using.
And the command host name.
And the command host name. Oh. Okay. And you can use the command host name to see where you are. There we go.
I'll tell you, yesterday I had 4 different windows open on 4 different machines, and I kept forgetting which machine was which window. So I'd have to type host name and go, okay, this one's on this computer, this one's on this computer.
Yeah. So at any point in time, if you are uncertain of which folder you're in, you can use the command pwd, which is path to working directory. Well, yeah. Okay, so you can hit pwd, print working directory, enter, and then that turns into the directory that you're in at the time. So in this case, I'm in my home directory, which is, oh, what's going on?
Okay, I got it.
Okay.
It's okay.
They won't open all the way unless you partially lift them. Now it should set.
Things are working very well this morning.
Hopefully you don't have to pull the HDMI out and back in.
Oh no, okay. Fingers crossed. While we're here, I have a pun for you guys. Why was water scared of TAE?
Why?
Because TAE is buffer.
Ten out of 10 joke right there.
My last lab didn't like it.
Come on.
That's okay, yesterday, you know how we talked to you guys, Tim?
Let's
I went
unplug.
upstairs and my news feed had a meme on it that said, I've been using Vim for 2 years now, mostly because I can't figure out how to exit.
Oh, that one's got it.
I thought you'd appreciate that.
This one formatted too.
It just takes it a minute.
Oh, okay.
It's there. It'll get brighter as it sits.
These darn fools.
Great. So the last command I hit, just to review before we went on the stand-up comedy, it was pwd, which stands for print working directory. Since I just signed in, I'm always going to be deposited in my home directory. So that's always going to be users / your username, which for me is @ed2562, and you can see that right hizzle. So from there, once we have the working directory printed, we can actually go about changing directories, and that's the command I mentioned to you guys before, cd, which stands for changing directories, change directory. First, let us create a directory. And the way you can do this is make dir, which again stands for make directory, and like any other command, if you need help understanding how to use it, you can -- help. So we're going to make a directory called make dir, and we're going to call it workshop day 2. And with any of the different, anytime you want to make a directory, you want to make sure there are no spaces in your name. Otherwise, the make dir command is going to assume that you mean to make 2 separate directories. So like this makes one directory called workshop day 2. Oh my, what happened to my computer? Okay. I made a directory -- help. That was my bad. There we go. Okay, so make dir, and that'll be workshop day 2. So this is going to make 2 separate directories, one called workshop, this is workhop, and the other one called day 2. However, if I leave the hyphen between them, we end up with a directory called workshop day 2. So make your directory called workshop day 2, put the hyphen in it, it's going to be one directory, hit enter. How do I clear the terminal?
Clear.
Oh.
Type the word clear.
Okay.
Yeah, it is.
There you go. And if at any point you're having problems like I am where your screen is taking up too much space, you can hit clear and it'll erase everything. Okay, so let's make sure that our directory was made. You can use the list command, so ls, and anytime you apply that command without giving it a directory to go into, it'll go wherever you currently are. So ls, you see you've made your directory, workshop day 2. I'm going to take a moment now. If you guys want to do stickies, see if anyone had problems making their directory.
So we have a green note if you have a directory. Woohoo! Very nice. Like everybody made a directory.
Oh my God, it's like I'm staring into a field. There's so much green. Great. All right, so our workshop day 2 directory is made. And now, the moment you've all been waiting for, you can actually cd into this directory. I know, it's a game changer. So we're going to type workshop. And what I just did there, you saw some magical letters. What, do you have a question? You saw some magical letters pop up. You can actually tab complete. So if you type in enough for your computer to know where it's going, it'll actually do the rest of it for you. So I'll show you again. Type in work, and then hit tab, and then that auto-completes for me. So workshop day 2, hit enter. And now I'm in workshop day 2. Can I be certain? Well, there's a command we've gone over that you can use to find out, pwd. And as you can see, now my path becomes users, @ed2562, and then workshop day 2. You know we're in the workshop day 2 directory. So that was the cd command. Now we're going to, in here, make more directories. Does anyone know if you wanted to make more than one directory, how would you go about writing that command? Exactly. You guys are so smart. All right, so we're going to make a couple of directories, one called bin, one called scripts, and I'm going to turn my sheet over, and one called data. And there we can hit enter. Did we make our directories? I don't know. What does ls say? We've made the directories. So I'm going to give you all a second. Anyone?
Green sticky note if you have all 3 directories.
So good. Okay. Your bin script. All right. What's your question?
So if we make those three directories all within the workshop next group, if I wanted to use
Oh my God, this is a great time to talk about relative and absolute paths. How dare you? Yeah. All right, so if you want to use a command not in the directory that you're in, you can actually type in your command and then, so right now you guys know I'm in workshop day 2, right? So you can type in your command and then you can apply your, your directory path. And so that's ls list users @2562, and that's going to list everything in the @2562 folder. Similarly, if you wanted to make a directory, make dir, don't follow along, this is not going to be a helpful directory for you guys, okay? But just keep this in mind. If I wanted to make a directory under users @2562, then I can just put a name, let's say audience plant. I need the space in there. There you go. And now we can ls, and I'm just going to show you guys real quick. If you scroll up, you can go back and reuse your previous commands without having to edit them, so that can save you some time, and you can do that with the cursor on your computer. So ls, user @2562, audience plant. And that's because I typed in my command and then used the absolute path. So in terms of directories, this is all hierarchical, right? So if you have your folder and you don't give it any sort of direction, any command that you will do will be placed into that directory. If you give it a different absolute path, then the command will be placed into that directory. If you put Seinfeld in your folder, I'm not going to know unless I go directly there. Which actually did happen last place I worked. Someone was using the cluster for high-C analysis and then also watching Seinfeld at the same time. It was a good time. I would never know if you guys were doing that unless I went directly in, because you have to go through all these folders. And that's absolute paths. If you wanted to use relative paths to do a lot of this stuff, you can. And the way you do about that is using this dot structure. So let's say cd, if I type 1 dot, that just takes you wherever you currently are. 2 dots takes you back 1 directory. And then /... takes you back 2 directories. So we can use this with the ls command that I've been showing you guys. So ls dot, and that'll show us everything where we are. And then that audience plant should be there. All right, and then ls ... This is the relative path for 1 directory up. So we're going to go ls, and now we have 2 folders up. This is the list of stuff we have in that directory. And if we were to do ls ... that would take us up 2 directories, and we have a bunch of names here. That's all of you guys, I think. So that is how that relative stuff works. The last thing, if you type in cd anywhere where you are and you don't add any other directories, you actually will just go back home. And we know that because you can pwd, and our home directory is always going to be users and then our username. Now let's go a little more in depth into the LS's. So ls is a command to list all your stuff, right? ls -l gives you a detailed list of what is in the directory where you're applying your command. So here we have all of these different things, just the 2 folders, and it tells you a bunch of different things. So here is like permissions, what you can do to all of it. Then you have where it is and the day it was made. And that is ls -l, it's your detailed list. Then
-L stands for long. You want to remember why. Long list.
oh, it's a long list. Okay. Then ls -a will give you just a list, but it also shows you hidden directories. So bash history, bash logout, bash profile, all of these things that are super important and you probably shouldn't be messing with.
How do we know that they're hidden?
Because they did not show up when I used the just the ls minus L command.
What makes them hidden?
Oh, I don't know. Oh, it starts with a period?
Yes, you can make it hidden by putting a dot in front of it.
Oh, that's cool. Okay. Is that,
Question up front.
What is the point of having directory?
Ooh, good question.
yeah.
How would you hide a directory?
I mean, I would hide a directory for secrets, but I don't think that's the reason in this case.
Kind of.
Okay.
We don't want people who don't know what they're doing messing with those files.
Oh, cool, awesome.
So the computer hides them. Windows hides everything from you guys. You have no idea how much crap is on your computer. Linux hides it, but hides it in a way that you can look at it if you know what you're doing.
Is that like freeze things out?
Yeah, so the bash profile, bash RC, do you remember yesterday when we said you could make A equal to 5 permanently if you wanted? That's where you do.
I see.
But they don't want people who don't know what they're doing it. So they hide all those files.
Awesome, thank you.
Yeah. As Mary was saying, all these are super important. Bash profile.
Don't mess with if you don't know what you're doing.
And I don't know what I'm doing, and I'm teaching the class, so.
That's normal.
Yeah. All right. So then that was minus A, and then ls minus h is the last one I want to show you guys. And that just makes all the information human readable. And it looks really similar to ls.
It only really matters if you add the L there.
Oh.
So H and L together.
Okay, yeah. Oh, that's a great time to show you guys the clear command again.
So the nice thing about human readable, and all they need is, when you did the ls-l the first time, you will see that the bits, go ahead and do ls-l by itself. The bits are in 6144. That's like Harvard. And so if you push the ls-lh, it will change it into something you can read easily. 6 KB, that I can read. Maybe it doesn't matter when I'm at 6,000, but when you end up at like gigabytes full of data, your number will be this long and you won't be able to read it. So if you just add that -h, it then translates that number into something that you can read.
Yeah. And this is a great time to mention that anytime that you want to apply more than one flag, you actually can. So I just showed you ls minus LH. You can also do minus LAH. And that'll give you even the hidden directories in a human readable format. So you can apply more than one flag at the same time.
Can I show you my favorite one? I know we weren't going to go over it, but my favorite.
What's your favorite?
My favorite is to add a TR.
Oh,
So do ls-lh TR.
Lotter.
TR. So T means sorted by date and R means reverse. And the reason I like that is because my home directory has over 1,000 files in it. So I can never find what I want.
Which is poor organization.
Yes, it is. I'll agree with that. But if you are working in a directory, if you need to know the last thing you were working on, if you have a TR there, it'll put it at the bottom of the list.
All the flags and commands like that.
Oh,
Good quiz question for the audience. I want to know what flags are available for LS. How do I check it? Actually, I already mentioned this. Help. ls-help.
so I'll show you guys real quick. ls-help. If only life were that easy, am I right? Alrighty. So, now that we've done all that, oh yeah, one more thing. ls also, again, with relative paths. So ls dot shows you there, and then ls, oh, I showed you this already. Well, in case anyone else needed to remember it, you can use the relatives again, and that'll show you stuff from other directories, as well as if you did it with the absolutes. Okay, now that we have a bunch of stuff that we've learned, let us generate some directories. PWD, where am I? Great, I'm still home. So we're going to cd into workshop day 2. And then from there, you're going to make your directory contents. So I actually also forgot one directory that we need. It's bed files. So once you get into workshop day 2, make a directory called bed files. And let's make sure that we made it. ls. Great. Don't make an audience plant folder. Not that I needed to be told. All right. Where am I? let's make sure that I'm in workshop day 2, PWD, great. And then from here, we can start moving files, and you can do that with either the copy or the move commands. And I'll show you real quick how to do copy. So that's going to be CP, and we're going to, oh no. Mary, do you have the file structure for?
Read over, it's scratch,
Okay, scratch.
shares, public.
Okay, scratch. No, I don't know how to spell. Scratch. English is not my first language, guys.
Shares,
Shares,
make sure capitalization are right, public,
public,
S-read,
S-
SR, and then tab, yep.
S-
S-read 2021, and then the same directory structure it was for the S-read folder after that.
okay, let's read bad files. That didn't work. Okay.
It's probably
Day 2.
day 2, yep.
Oh,
Data files first, I think.
Data files in day 2.
day 2. I'm going to zoom out. There we go. Day 2, and then there is bed files. And then from there, we're going.
See how often he's using tab, you guys should be using tab that often too.
Yeah. Okay. So I found the file. It's under Scratch, Shares, Public, S-read, Data Files, Day 2, Bed Files, and CHR1. I didn't know that by memory, but thankfully I could tab complete a whole bunch of times, and that made it a lot easier. So don't forget to use your tab completes. I'm going to wait for everyone to get that written down, and then once you have your directory written down, don't hit enter, just give me a green sticky.
Don't hit enter yet.
Is this something that we need to write down if we want to?
No. Okay. Seems like most people have got it. So that's CP copies from one place to the other. So our first place that we're copying from goes first. So in this case, it's going to be the CHR1 bed files file, and then we can copy that into our bed files directory, and we can do that using an absolute path. So like all of our paths that involve us, we're going to start at home. So users, and then this is going to be your username. 2. I'm going to zoom out some more. And again, the second set of instructions is where you're going. So from there, we're going to go into workshop, day 2. Feel free to tab complete. And then from there, we're going to hit bed files. So the structure for the CP command, again, is your file / directory, wherever it's starting, to where it's going. So in this case, it's going to go into my bed files directory, and I'll hit enter. And then I can use ls. Under bed files, we can see I now have that file. Everyone's going to give me green stickies once you've got it copied into the bed files folder.
In the copy function, how do you have two different absolute paths that start in a different folder?
Yeah, so the absolute path, I'm going to draw.
Can I crack a joke while you're?
Yeah.
Okay, you draw and I'll try to do it. So my ex-husband, and I'm not making fun of him because this is true of everyone in his family, they can't do relative paths. And so if they need to go from store A to store B, they will go home in between. Because they do not know how to do directions between two stores, they only know how to get to store A from home and to store B from home. And therefore, that is absolute paths. The very top of the directory, that first slash tells you you have an absolute path. If your path in any of these starts with a slash, you are starting at the top of the computer. Okay? So both of those start at the top of the computer. If you are in your own, if you're somewhere on the computer and it does not start with a slash, that means you are doing relative. So the only thing you need to key off of, does the path start with a slash? Start with a slash means start at the top of the computer. Don't start with a slash, starts from where you are. And I'm pretty sure my daughter has the same problem. Because she went to the park, walked over a bridge, turned around, came back, and went, look, another park! Go ahead.
Okay, yeah. So this is what I was going to say, is that these directories, as I mentioned, are hierarchical, so they're kind of shaped like a tree, right? And again, you start with the slash, as Mary was saying. You're going to tell it to start with the beginning of the tree, and then as you put in more directories into your path, you're going to move down the tree until eventually you get here. But let's say if you're already at the top of the tree and you want to use like ... then that'll take you back here. But yeah, using two absolute paths tells it exactly which direction to go. Relative path can only tell you, like, I'm here, go back here. Okay.
As well, you've got two inputs for this particular command. You've got one that's the target file and one that's the destination. So you've got to put a path for both of those.
And if you did dash dash out, that's what it would say. The way you run copy is copy from to.
Okay.
Challenge question, PWD real quick.
PWD, was that a challenge for me?
No, challenge question for the audience. What's the other way he could have typed the to command, depending on where he is?
So, she means, oh,
What's the other thing he could have done there instead of full path? Look at where he is and where he wants it to go. Bed files, there you go, bed files with a slash, would have put it in the same place.
yeah, so that would look like this. And bed files is in workshop day 2, yeah.
What? You have to put a slash at the end, you do not put one at the beginning.
If you don't put the slash at the end, it will take whatever you're copying and name it bed file.
Because it assumes that what you want is a file named bed files. And I assume it would error on that because you have a directory named bed files.
No, it'll allow you to have
Oh.
it.
And directory, oh, that's terrible. Yeah, don't put it in slash. Slash means put it inside of this directory. You got a question in the back?
Question in the back. Okay. Alrighty. So, as I showed you guys before, let me copy this. CP.
You will learn in Linux there are always 7 ways to do something.
And
All you got to do is figure out one of the 7.
yeah, so here's another way you could have done it, and don't do this, but if you needed to move a file instead of copying it, as in you didn't want your original file to still be in its starting directory, you could instead use mv, which is move. Obviously don't do that because that would move the file for everyone else.
Pretty sure they can't. I think I locked it down.
Good call. But if you ever needed to move stuff. And then the other way you could also do this is rsync. Still don't know how to spell. rsync. And that just, again, will copy things for you. And this is particularly useful if you need to copy things from a server onto your computer or from your computer to your server. Okay. Last thing we're going to... Oh yeah, sorry. I zoomed out so you guys could see the whole path. Yeah, no problem. You would use SCP, which is server copy. Secure, sorry. Secure.
So you use rsync more often when you're doing it because our thing is if copy dies in the middle of it, it tells you nothing. So if you give it a big file and the command happens to die, you will get no awareness of this fact. So then they invented secure copy transfer, which is SCP. That was, we will give you an error. However, if we give you an error, you just have to start the copy all over again. And then someone invented rsync, which is even smarter because it starts to copy things, and if it dies and you run the command again, it starts over at where it died, rather than starting over from scratch. So even though CP, SCP, and rsync look like they're doing identical things, and they handle errors differently. And so most people just use rsync because that one handles errors the most gracefully. Yes, and I do most of the time. The only time I really use CP is when I'm like copying a tiny text file. I use rsync for almost everything instead.
Okay. So now we want to check that our bed file moved into the right directory. So we'll go ls bed files. Whoops. Type complete. And enter. that's a chromosome 1. All right, let's cd into our bed files directory. And now that we're here, pwd, again, to check where you are. The last thing I'll show you guys is the move command. So you can use move command obviously to move things around, but you can also use it to rename stuff. So we're going to hit move, right? That's going to be our command. And like with anything else, you can hit move -- help to figure out what to do. And then you can hit clear. So we're going to hit move, and we're going to type in our chromosome 1 bed file, and then you can type in the name that you want it to have at the end. So you can rename this to CHR1 bed files. And again, all of these namings and things are in your worksheet if I'm typing too slow for you. bedfiles.tar.gc. And yeah, once you rename it, it'll have the name that you gave it. And that is how the move command works for renaming stuff. Just one last thing before I go, is that you see this file has a .tar.gz extension. This is a compressed file, so it has a bunch of other things in it. And I'm not going to show you how to do that, but Sam Hunter, who's going to be teaching you guys next, is going to show you how to do that. So before I go, are there any questions? No?
Okay, let's take a break while we switch to Sam. Oh, we have someone with a question. Go ahead, question.
What up, sis?
Can you, when you rename things, can you like accidentally remove extensions? File types?
Yeah, and you should definitely not accidentally remove extensions or change file types.
So file types is not real.
Yeah.
File types is an illusion that Windows has given. There is no such thing as a file type. The dot something afterwards is just something we add so we know which program to open it. Which means Linux is smart enough that you don't have to have dot anything.
But you're not usually smart enough to remember. So the name is something informative.
And that does remind you, so when I have a tab delimited text file, I name it txt. And when I have a bash script, I name it .sh. Tomorrow you're going to learn about sbatch. When I have an sbatch, I name it .sbatch. So that I can remember what it is. It is not required by the system. It is on Windows because Windows doesn't want you to make a mistake. But it is not in Linux.
So that is a fundamental tenant difference between Linux and any other operating system. Linux actually thinks you know what you're doing. Which means if you copy a file over and you name it something that's already in that directory, it just writes over. If you...
Which a lot of times is what you want.
Could be what you want.
Write output again.
But they don't check.
But it does not do checks for you automatically. On anything. Which means when you remove a file, it's gone. Forever.
Another fun thing about that is file extensions, because they're basically just made up for humans only, is that anybody who's trying to, virus up your computer or something like that can just name it like a open it and it'll run a script or something like that. So, yeah. Just a quick warning.
Okay, let's break while Sam switches computers, and then we'll come back in a few minutes and Sam will keep going with how to run around Linux.
If you take anything from this, let it be that it's socially constructed.
5 minute breaks, that's right.
Okay, 5 minutes. Do you need the computer?
I'm going to check to see if this works.
Yeah, because mine started doing that as soon as you left.
I was going to say, I saw yours was not working as well, so I'm not thinking that maybe...
Thanks.
Very good job. Much, much, much better than my first time teaching. So. Yeah, you did great.
Good, I couldn't have done it without Mary's help.
Well, I mean, Mary and I will you can teach the best that you want.
Oh, dude, you got it printed out. Such a good call, honestly.
Yeah, well, so I had printed out, but I left it at home this morning because I was in a bit of a rush. Once again, my little kid was feeling sick. So, I don't know what's up with her, but
Well, I'll leave my computer in the wings.
That would be great, yeah. I'm gonna,
If you run the 0.11.5, it'll run, but it gives a excellent error, which I'm not sure if it's just.
so, is this guy not plugged in now?
Yeah, so let's try that one, because this one was not working.
Yeah, so,
So you gotta go to VGA.
oh, I see, that's why. I forgot that this thing has. Try reset.
Your machine does not act like it even sees that.
It does not at all, does it? Yeah. Is that Zach's that he brought down, I assume? Okay. Well, I can always just use REOs. That's fine.
Try this one more time.
I will, but
It didn't work for Mary, actually.
yeah, no, I saw her having some issues with it as well. Just, it would flash and then turn off, right?
Yep. Suggesting that might be the box. Let's go back to HTML.
Thanks. See, this one detects it. It says mirror displays, but it does not.
Doesn't display.
It doesn't display anything. So, under. Nope. I was gonna say. That's why you. They always say when you're making a test or something for a class, you do easy questions first to build up their confidence. Because if you do the hard question, they just collapse in on themselves like a dying star.
The hard questions first, and the rest of the wheels.
Yeah, that's fine. Hopefully he doesn't mind. I guess I'll have to use
Does
his.
it act like it understands that?
Yep. Yeah, so we're doing fine on that. I guess that means I'll also have to use his. Probably have to use his login too, because this isn't going to have my key. So, very fun stuff. Yeah. Ariel, I hope you don't mind. I'm just going to be in your login for this.
That's okay, yeah.
So, yeah.
I just submit files.
Yeah, you've got audience plant too. I wasn't expecting that directory, but
We need to figure out what
yeah, that's really strange. It's got to be a Mac thing. I don't. Yeah, which is really strange. When on earth has Windows worked better than Mac for something like this? I know. I was gonna say, is there wouldn't.
opening the door by curfews.
Sam, can I work on your computer quick?
Oh yeah, sure.
You just switch.
Let's just switch computers.
You'll be on my login. Oh, great, great. Call me Sam.
I also want to be called Sam though, so
Oh, okay.
sorry about that.
Sam and Sam.
Sam and Sam. It's not that I don't like your name. It's just.
It was the old Sam.
Oh.
His name was Sam, I don't remember, but I said, she goes, who is that? I'm like, Sam. I'm like, the old Sam. Oh, got it.
Yeah. I am one of 3 Samuel Hunters on this campus. So, like, it's a pretty common name.
He wasn't even sitting down.
Mm-hmm.
And he made some of the videos.
Yeah. I was gonna say, what's great about teaching the Linux section is because it hasn't changed in 50 years, we don't have to change any of the videos. The only one we have to change is the host. So, which is great. So.
I think we're about ready. Has it been 5 minutes?
I think are we missing some people? I was gonna say, weren't there some people on the row behind you?
We'll wait.
So yeah, I'll give it a little bit more time. But.
Time is like extension, very socially constructed.
Exactly. It's like the Spider-Man thing, ultimate power, no, wait. What?
With great power comes great responsibility.
That's Linux right there. With great
Yep.
power comes great responsibility. You are now allowed to do stupid things.
You can really mess yourself up, yeah.
Why they swap down everything in our circles, so we don't do stupid things.
Maybe I was mistaken. Maybe there isn't anybody behind you, but I thought I saw someone. All right.
We'll catch up.
Yeah, we'll just get started, I think. All right. Everybody come back to class. Oh yeah, sorry. I guess let me know when I am hearable. I don't know.
You really have to put it in your mouth.
Oh, do I have to just swallow it here? All right.
What if I turn it up? Does that work?
Hello, testing. We doing good? Okay. All right, I'll just lean in. That's great for my back, which is already a little slouched. All right, so Ariel taught you how to navigate through these file structures. He taught you about how to copy files over, how to rename files, how to move files. We're actually going to start digging in how to look at the files themselves now, which obviously is pretty useful when you're trying to manipulate data or look at data in any way. So this part is going to be, again, we're going to move pretty slowly for everybody. You are welcome to work ahead by looking through the worksheet and through the slides. Basically, everything that I'm doing is just going to be copying off of the worksheet and explaining it in more detail. So again, if you're feeling like you're falling asleep or something, work ahead a little bit. But yeah, so let's go ahead and try and open this tar file. So the first thing that Ariel mentioned is that this is not actually any sort of readable file right now. This is a compressed and archived file. So the first thing we need to do is decompress it and extract all the files from it. The command for that is tar, and as with everything, we can just check what we need to do to run it by typing tar-help. And you're going to see that it's going to give us a whole bunch of flags that we can use. I am going to spoil it for you here and tell you which flags we actually need. So we are going to do tar. Whoops. Oh, I see the issue we're having here, Ariel.
Yeah, you gotta clear it sometimes.
Yeah. Oh.
Between the 5 of us, it's one working computer.
Oh, that's not how you spell clear. Okay. So tar, X stands for extract. V stands for verbose. We want it to tell us what it's doing. Z stands for unzip, and F is just going to be our file target. So we are going to do that. It doesn't need a dash, no. No. Oh, are we? Where are we? I'm going to turn your volume down because that's getting really annoying. Oh, we don't want to listen to Revenge Party. All right, maybe we're supposed to be embed files? Yeah, okay, now we're good. So, yeah, we'll check and make sure. There's our file, awesome. Okay, so tar, X, V, Z, F, and then chromosome 1. And it's going to tell us exactly what it's pulling out of that archive. You can see it's these two. These are what we call bed files. We tell ourselves that they're bed files by putting the bed extension, as you know. So let's LS/LAH just to make sure we got everything. And hopefully all of you are looking at what I'm looking at here, which is some files with ENC, FF, blah, 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 blah. So green sticky note once you have extracted these and are looking at this through LS. Yep.
Can you explain how you know when you need a dash and when you don't need a dash?
Oh, I think that the dash actually works with this one as well. Hold on, let me try this.
You read that help.
Yeah.
It'll tell you in the help.
I was going to say,
That help thing, 'cause
yeah, it works just fine. I was going to say, the worst thing about all of this is a collaborative project. You know, lots of people wrote lots of programs, and there is no standardization for any of them.
There is a standard and people don't follow it.
Even better. So, you know, one of the things that's really great is, for example, a lot of the commands that Ariel showed you, he typed --help. Sometimes they don't even write a help flag, they just write an error flag. And so help is throwing an error that then tells you what to do for it. It still works, but you know, it's much better to have the document. While we're on that subject, actually, if you ever want more in-detailed help about some of the bash commands, you can actually do man. And so let's do man for CD, for example. And it will give you a big, long text document about what you need to do to actually run the file.
it should give you a big, long text document.
Yeah.
Again, that's a standard people are supposed to follow. They don't. With Unix, it probably will, because the people who wrote Unix follow standards. With bioinformatics software, People suck at following something.
Yeah, well, I was going to say, this is basically only for Unix commands. So far as I know, bioinformatics commands are just going to fail every time you try and typing man, but... All right, any other questions? Oh, you mean like, yeah. So yes, the colors are actually related to, I mean, it's something that your terminal is actually going to colorize for you, and that's based on your program as well, but they also represent the file permissions, as well as certain file types. So in this case, you know, for example, these over here are the different permissions for different groups. And so the one on the far left, these three on the far left are for the owner, three in the middle are for the group, and then the three on the right are just for everyone else. And yes, and yeah, they basically just stand for what you can do to the file. Can you read it? Can you write things to it? Can you execute the file? And like Mary said, we'll go over that in more depth. But
That's probably great because it has the executable flag on it for some reason.
yeah, I don't know why. You know, I was going to say this one. I think you're right because it does indeed have an executable flag for the group. Don't try and execute the tar file. I imagine your computer will crash. So.
They probably won't give it a bunch of it.
Well, yeah, it'll throw a flag, but okay. So everybody has these files. Perfect. All right. So we can go ahead now and start trying to look into these files. So, you know, we've moved files around, we've copied them, we've renamed them, but what's actually in the file? Well, like with everything, we can check what's in this file through a bunch of different means. You've actually already learned one. Anybody know what you would do to look at a file or possibly edit a file? I heard Vim. Somebody said it. I heard Vim. Vim lets you edit files. That's correct. I would highly recommend basically never using Vim for anything but scripts, because Vim is going to let you actually put stuff into those files. So if you Vim a data file, you can add whatever you want to it, which is falsification. You don't want to do that.
That's how you get into nature.
Yeah. Oh, yeah. There we go. That's how you get out of nature, too.
Only after a decade.
Yeah, when you get caught. So yeah, Vim is one way that you could technically look at a file, but you will also be able to edit said file. So we don't really want to do that. We just want to print out the contents of the file, which is for good practices. So the first command that we're going to learn is the command head. As with everything, we can type help, see what we want to do. And as you can see here, head says that it prints the first 10 lines of each file. So if we do head and then just give it a file, it's going to print out those files. Hold on, let me clear my screen again. Yep. So let's do head for one of these files, this ENCFF050. And would you look at that? Yep, always tab complete. It'll help with typos. So, oh yeah, let me mention that actually as well while I'm on the subject. So, with tab complete, you notice that if you type in just ENC, it's only going to tab complete like a little bit of the word. Let's say you didn't remember what file was there or anything like that. If you hit tab twice, it's going to show you a list of files.
It shows you the options that have that prefix.
Exactly, yes. And then you can just say, oh, well, I wanted that 050 file. Hit tab again, and it'll autocomplete. Okay, so let me do this all again because this screen is kind of funny. Can I just shrink the screen down? That might help. Maybe?
The mouse doesn't work.
Oh, that's excellent. I really, yeah. No, I'm not missing my Mac at all. So can I, there we go. Okay. Let's see, so do this one more time. And now it's looking real ugly.
Yes, but you're showing them what happens when it wraps.
Yes, it is indeed wrapping
You can't
all.
get on your screen, it wraps around to the next line.
What's the Windows hotkey for shrinking text size?
For shrinking what? Oh, you can use the mouse and just do the.
Oh,
Well, that's probably why you were,
There you go.
that's probably why it's having issues, is because it's not actually, okay. We're all on one line now, so let's do that. Okay, so we have printed the first 10 lines of this file to our screen. This is a good time to talk a little bit more about what I was talking about before, which is that with something like Vim, you are actually in the file and editing the file and writing to the file. With something like head or any of the commands that we're about to talk about, you are just printing the file output to what's known as standard out, which is just basically saying you're printing it on the screen. Now, we will learn how to actually save the contents of standard out a little bit later, but for now, just know that when you're using any of these print commands, all it means is you're just going to show the output. All right, so head prints the top 10 lines of that file. The reverse of head, anybody want to guess? Tail. Perfect. So if we do tail, whoops, we will print the last 10 lines of that file. Amazing, right? All right, what if we wanted to print, 20 lines? There is a flag for that. So if we do tail-n 20, we're telling it how many lines we want to print now. So we could do that.
And if you didn't know the flag, what would you do? Thank you.
Help. Or if you really wanted to read about tail, you could do man. All right, so now we printed 20 lines. Amazing. Well, printing lines is great, but you may not know how big this file is, or you may just want to scroll through it at your leisure, so it'd be really nice to have a program that scrolls through, right? Well, Linux thought of that too. So we could do more for this, and that allows us to just scroll through at our leisure, starting from the top, going through the bottom. So if we just hit the space bar, it will scroll through this file for us. And when it gets to the end, it'll just exit us out of more. All right, more is pretty bare bones. It's not really going to let you do anything other than scroll through the file. So if you wanted a little bit more functionality, you could use less, because less is more. Yeah, they have a sense of humor. And it's not a good sense of humor, but it is a sense of humor. So less is nice because not only can you scroll through the file, but you also have a little bit more functionality. There are some hotkeys. For example, Shift-G takes you to the end of the file. I think it's lowercase g takes you to the top of the file. You can type in a file line, and that'll take you that many lines ahead. They also have some basic search functionality as well in less. So it's just basically a more functional more. Now, how do I exit less? Yes. If I just type Q, then it's going to get me out. It's very similar to Vim in that regard. It has a lot of the same hotkeys as Vim. So that is going to do the exact same thing, as I mentioned, as more, with just some more functionality. We are going to get to that, Robin, so just give me a second. One other thing before we get to that. If you just want to print the whole contents of the file to your screen, you could use the command cat.
Again, if you don't know how big it is, I would not suggest catting.
I'm gonna say it will
Keep going until it is done.
It will keep going. So if you have a line, or if you have a file that is, millions of lines long, it will just print for hours. Yes. Oh, how do you stop it? Yeah. If at any point your computer stalls out, you can always just press Control-C, and that is going to kill whatever you're looking at. It's actually, I think if we do something like, we'll say CP and then put like a quotation mark, let's say, you're like, oh, what did I do? I don't know what's going on. Just hit Control-C, and it'll exit you out of whatever you were typing or doing. So it will also not save any of your output though, so if you Control-C during a command, it's going to stall out in the middle of the command and just kill everything. So. Okay, so we've printed out all of these contents of these files. As Robin said, we can also get a little bit more information about these files. So if we do the command WC, that stands for word count. We can check and see what word count actually does. It's going to print our lines, words, and byte counts from each file, as you can see right here. And all we need to do to get it to work is just point it to a file. So we can do word count for this bed file, and you can see it gives us 60 new lines, 540 words, and 3889 characters, right? If you just wanted to get the new lines, there's a flag for that. There's always a flag. Oops. I know, always typos.
Totally normal.
And you can see it's just going to tell us that this file has 60 lines in it.
I
So,
want to know how big it is, how many gigabytes or kilobytes it is. Learned it earlier. LSSL,
ls-l.
LAH if you want.
Yeah, we can make it human readable. All right, and look at that. We are 3.8K for this tiny little file, so.
So my order of operations, which you do not have to do, because of course you can do anything you want, is to first do this, because I do not want to accidentally less on a file that is 2 terabytes big. But then check how big the file is before I start messing with the commands, because then you optimize which commands you should be running on.
I usually do head, because,
Same thing.
yeah,
That'll give you an idea of what the file type is.
exactly, so. All right, so now, speaking of head, I'm going to go ahead and print this out again, just so we can take a look at what we're looking at. Actually, before I move on, just want to make sure everybody clear up to this point. We've all perused this file a little bit, and we know all the commands. Any questions? Perfect, all right. Well, we are going to move on then. Well, so this file, just to give you a little teaser for what's coming up next week, is a genomic coordinates file. So it's telling you the chromosome, the start location, and the end location of some region of interest. And then it's giving you a whole bunch of other information about that region of interest, and that is going to be program dependent. But maybe all you really care about is, let's say, those first 3 lines. You just want to know which chromosome it's on and which location on the chromosome it's at. So we could actually parse this file a little bit better by using a couple of different commands. So the first one we're going to learn is cut. So cut lets you specify columns that you want. So let's say we just want those first 3 columns. We do cut -f, 1, 2, 3, and then just point it to the file. And there we go. All we have is those first 3 files now. So that lets you just kind of cut down on some of the information that the file is going to be giving you. Let's say you wanted a different column. We could just add in whatever column we want. Maybe we want column, I don't know, my favorite number is 6. There we go, we get a whole bunch of dots. So.
This command just prints, right?
Right, so right now everything is just printing to the screen. So if we were to do head on that file again, you will see we still have the full contents of the file. We haven't actually edited the file in any way. All right. So, everybody clear with cut so far? Awesome. Sure. So, cut. Here, I'll do the help command too, so we can read a little bit about cut. So, cut is going to print selected parts of our line. We are going to use this -f flag so that we can select which columns we want. And then we just enter the column number that we want. So.
Can I point out one more thing?
Sure.
One of the standards for help menus, again, bioinformatics people don't always follow it, but they should, is that you see the very first line, the first line is almost always usage, and that line tells you how to run the command. And what's most important is that things that are not in brackets are optional, and then things that are in those brackets are required. So cut cannot run if you don't give it a file. That is required. It also tells you the order, which is almost always the command, the options, and then the requirements.
Yeah. One more thing is that if you scroll through these files, a lot of the times they will show you that there are some mandatory arguments that they've given just defaults to. So for example, this delimiter argument, they have just said that tab is your standard delimiter, but if you had a comma-separated file, for example, you could use, cut D and then put a comma and then F and do the rest of it. But for brevity, we will just do this. And that is how we run that command. So just cut -f, and then the fields that you want out of that file. All right. Everybody clear up to this point? Cool. So let's talk a little bit more about going through this file. Maybe there is a specific part of this file that we're interested in. For that, we can use grep. So grep is just a pattern finder. So we can look through this file and ask it to return anything that matches a pattern for us. So if we wanted it to return every line that had a 151 in it, for example, we could do that. And it's going to, very helpfully, for a lot of programs at least, going to highlight where it found that 151, and then it's just going to print those lines to our standard out. So you can see here that we have 151 in this column over here, 151 over here, 151 in column 3 for that bottom one. But maybe, that's not particularly useful. Maybe you don't want it so that it's nested in these other values. You just want it to print it if it's a whole word in and of itself. So there is a flag for that, as with everything. Grep-W means only if this is its own complete word do I want it to print. There is nothing in there with 151, so it's not going to print anything. All right. And to show you the converse of that, we want everything on chromosome 1, for example. We can do that, and you can see that it's going to print everything in that file because everything's on chromosome 1. Yeah?
So what if it's like a section header and we want a number of lines after that instead of a flag?
Oh, so you mean like there's a header you don't want to go through and then the rest of the file you do want to search?
Well, or just like we know that somewhere in a document there's a header and the next 50 lines
Right.
50 lines after.
Right, so we're going to learn a little bit about pipes in just a bit, but basically one of the things that you could do is you could just cut the file to where you want it and then run your grep command on the file, like the part of the file that you're actually interested in. So we will get there. Okay. So as with everything else, grep has a whole bunch of really useful flags. I'll go over just one more of them, which is grep C. So grep C is kind of a combination of what you did with word count, but this time you're going to use the pattern finder as well. So it's going to print out the number of lines that match the pattern. So if you want to know how many regions you had on chromosome 1, you could use grep-c chromosome 1, and it's going to tell you that there are 60 lines in this file that match it. All right, quick quiz. How would we figure out how many lines of this file are on chromosome 1 as a percentage of this file?
Ooh.
So what do we need? Well, we could do variables, absolutely, but which variables do we need? So we need to know, first of all, how many lines are chromosome 1, right? And then we need to know the total number of lines in the file. So how do we get the total number of lines in a file? WC, perfect. So we can do that. And it is 60, so I don't think we need variables to do 60 divided by 60, but when we get to the numbers that are in the millions, we will definitely want to, yes. So.
My favorite one, since you're noting your favorite one is C, my favorite one is N.
Ooh.
Because N tells you what line number. So remember when it did earlier, so you don't want to do it on chromosome 1, do it on 151 like you did before.
Well, we'll do it on 235, how about? Because I
There
think
we go.
235 is a unique number, so.
There you go. So it tells you not only where is the line, but which line number it is. Which turns out to be really useful because if you got far enough in tutor, you learned that you could go to any particular line.
Yeah, smart. I actually didn't know about that one.
Yeah, I love N. That's my favorite grep flag. You will find out that different people have different favorite flags.
Yeah, it's somewhat sad in a way, but it's very fulfilling, I promise. All right, so everyone has played around with grep a little bit. Go ahead and put a green sticky note on your computer if you're with us so far. Okay, I'm seeing basically all green. Oh, one question.
So you found out
How do you go to the line number? Oh, perfect. Okay, so we could go to example in less, and then you can actually just type the line number. I think that actually, does that skip you the lines down? Does anyone know? So, yeah. Oh, 26G. There we go. So we could find, I don't even remember what number I typed. What was it?
Anybody know how to do it in Vim? You got far into the tutorial.
Oh, people didn't do their homework.
Learn how to get the line number.
It's the same way.
Colon, but do you need the colon? I always use the colon.
I think if you're in command mode, you can just type, but maybe. All right. Good question. So yeah, you can, yeah. 26. I don't even remember which number I typed. 235 is what I typed. Okay, so we can try this one more time just to make sure. And 235, there we are. So, all right. But what if we wanted to combine some of these? So 235 is great, but it's also nested in these other sequences here. What if we wanted 235 as a complete word and to give us the line number? How would we do that? The W flag, yep. So we could just add W here. And now it's going to do both of those things, right? So you can kind of mix and match flags to get what you want here. So now we're getting everything that's a complete word and matches the pattern 235. All right. Perfect. So we can talk a little bit more about manipulating the file output right now. There are a couple of just other really useful commands for something like this. So unique is going to just give you every line that has a unique value. For this one, obviously, since these are regions, every line is going to be unique, so it's just going to print out the whole file. But, oh, hold on. If I make, for example, a little list ball, let's say we just made an example list and we wanted to find the unique values in that list. It's going to print this list out with the -C. It's going to give us a count of those values. I think I left a space here, which is why this ball is unique. Hold on. Oh yes, look at that.
Spaces matter.
Spaces matter a lot. So let's try this one more time. There we go. All right. So we have 2 ball, 1 Unix, 1 Linux, and 1 ball. Why did that happen? What? Oh, so surprised. Why didn't it count that ball at the very end of the file as being part of the other unique counts here? Yeah, exactly. So it only works on sorted input. All it's doing is it's looking through this file and asking if the next line matches it, right?
It only works on sorted input, though, so you've got to remember about units.
Yep, so now we can learn sorting. Sure.
Did that change your file at all, or is it just changing the output?
No, so everything that we're doing right now is just printing output. We haven't learned how to actually change the file outside of Vim, which you shouldn't do on data files. So I'll repeat it one more time for the people in the back. Don't use Vim on data files. It's really, really, really bad practice.
Actually, when you learn permissions to learn how to lock a file, you should do that on data files.
Yeah,
Lock them.
absolutely.
You don't need to.
Yeah. Least of all you in a sleepless night. That's a joke. I know nobody here would do that.
You get another question.
All right. Oh, one more question?
Earlier when you were demonstrating the grep -w-n, you did those two separately. Could you also do them together, or was it
Oh,
-w-n versus?
sometimes yes, sometimes no. It depends on what the flag actually does. So if the flag doesn't require a value for it, then usually you can combine them. If the flag requires another value, then you'll have to separate it. Now, I say that, but again, it's very much dependent on the program, so there are going to be times when you do have to separate them. Just as for my own sake, I usually just separate all flags. it makes it easier for me to figure out what I've done, as well as, I know that I'm not going to run into an error because I didn't put the value for a flag right or something. Any other questions? Oh, sorry. The far left of the window, yeah. I actually do mine greatly because this mouse doesn't work, but I will suffer for you. All right, there we go. Okay, so we need to sort this file. Man, 3 guesses on what the sort command is. Sort. So let's sort my list. And you're going to see that it's going to sort ball into those 3 spots now.
Hey, add in there 2 numbers just so they see.
Yeah, sure. I was actually,
1 and 10, are you going to do that?
I was going to do that. So sort is going to sort your file. I'm going to really quickly jump back to our old friend, the bed file, to show you what happens when we sort that. Oh man, that is just lovely.
You could cut it and sort it. Oh, you
Yeah.
can't. I haven't seen what-
Yeah, I was gonna say, I'm gonna hold off on that just real quick. There we go. All right. So we've sorted this file. Does anybody notice anything about our sort here?
Any problems?
Is this actually numerically sorted, or is this kind of weird looking to you? Because it should be kind of weird looking to you. If we look on our first column, it looks great. We've sorted chromosome 1, but the first column was all chromosome 1, right? So when we look at our second column, these aren't actually in numeric order at all, right? We've got 1, 0, 0, 1, blah, 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 which is a much bigger number than the next entry. So it's not actually sorting numerically at all right now. It's sorting by this character here. And so, 1, 0.
Sorting alphabetically. If you ever remember how alphabetical sorting of numbers works, it is literally digit by digit.
Yes, so.
That your numbers get out of order when you sort numbers alphabetically.
So we're going 100, 102, 109, 113, right? And it's not actually taking into account that this whole thing is a number. It's just looking at the first character and then moving forward. So we want to do a numeric sort. So we can try sort-n, which is the flag for numeric sort. Oh my, why didn't it work? Right, yeah, so we haven't actually keyed it to any sort of field that we're selecting here, so it's doing a numeric sort on first column, and then it's just kind of going forward from there, okay? So we need to add in yet another flag. So we are fine with it sorting on that first column, so we do -k, which is a key for how to sort. So we're going to tell it to sort column 1 based on the values in column 1. That's what this notation is here. And then we're going to add in another key and do 2 based on the numeric values of column 2, all right? Now let's take a look at our output. And you can see we have actually sorted column 2 numerically. All right, so has everybody gotten that far? Green sticky notes if you've managed to sort your file numerically. Yeah. Sure.
K1, comma 1 is.
Absolutely. I will go to my old friend, the help bar. So K, first of all, N just stands for numeric sort. You want it, instead of doing it alphabetically, you want it to do it alphanumerically. K is the key flag, and so what that means is you're going to provide the program a way to sort based the column that you specify based on a key that you specify, okay? Now, generally speaking, you want to sort columns based on themselves, but that's not always the case. And you can read here a little bit more about it, but you are going to give the location and the type for that sort. So what we do is, obviously, for the first one, we want to do K, 1, comma 1. As I mentioned, we can just sort that one normally because, we want it to be alphabetical. We specify a second key, so we use that same K flag again. On the second column, we want that to be sorted based on the alphanumeric ordering of the second column. So we do 2, 2n, okay? And then we just give it the file target, and there we go. Okay?
Remember how we said you will have to Google it? Sort would be a good command to Google.
Yes.
Because it's tells you what to do, but it doesn't really tell you what to do. So order of operations when looking for help, check for man first, because man's going to be the most expensive help. Then check for -- help as your second. And third is Google it. Yeah.
Is there a way to like sort by column to Zen?
Oh, you are jumping ahead. You weren't our original plan, right? That was... So we are going to get there, but we will first learn a little bit more about actually saving our output, which, as you can imagine, is actually just sort of a roundabout way of getting to where you want. So I mentioned before that everything right now is just printing to standard out. It's just printing on our screen. What if we actually wanted to save that to a file? As you can imagine, it'd be very helpful to actually be able to save your work. So that's really easy. You put the command that you want to run, and then you just add a greater than symbol and the target that you want to save it to. So we'll call this encff050.chromosome1.sorted.bed. Sorted.bed. All right. So when I hit enter here, oh, I forgot the DnG, I guess, but so let's do that one more time. Let's be consistent. There we go. So nothing printed out onto our screen. Where did it go? Well, if we hit ls/lah, you can see that we have a couple new files because I made a typo. But the file that we really care about is this guy right here. We have saved a new file called encff050dng.chromosome1.sorted.bed. So now I want to look at that file. How do I look at that file? Shout out your favorite command. I had less, cat, more, anything, right? I'm going to do head because I really like head. Not vim, thank you. I am very glad that that's getting through to Mary, I guess.
That's right.
All right, so I'm going to use head because, head is really quick and doesn't really care about the size of the file. You can use whatever you want, but keep in mind that it is size dependent. And as you can see, when I do head, it is the same file as encff, only this time we have sorted that column. So we've managed to save our output now. There was a question about, well, how do we manipulate this? Well, this is one way to do it. You could save the output of one command and then use that as the input for a second command. So if we wanted to now check, I don't know, let's do this actually. So we can sort, I mentioned that we have my list. So this is something that I just made for an example here, which sorts my list because before my list, had that ball element out of order. So if we sort it, it's going to put ball with its friends. So we can save the output as this as my sorted list. And now we have that list in there. We can take a look, make sure it's what we think it is. It has indeed sorted that. And now we can use my sorted list as the input for that unique command that we learned before. And now it correctly tells us that there are 3 entries for ball, 1 for Linux and 1 for Unix. Okay? Yeah? Yes, there is indeed commands for putting things into the next command. We will learn that in just a second. So what do you think happens if I try and save a list to the same value that I'm taking the values from? So, yeah. So we can try, let's see, what's something fun to do this with?
Move the sorted list to the list.
Yeah, we can, we can do my sorted list to my list. So that's, oh my goodness, have I just committed?
We locked down data files.
So we have changed that file. And so that's something that you want to be careful of, is if you are saving back to the original file, you are destroying the old file. And not to mention, some commands are reading the file line by line. So if you're saving to the file and you're reading it line by line, you have destroyed the data before you've even gotten through the file.
So the real answer to your question is how big is what you're doing. Okay. So the thing we're about to learn is where you don't use intermediate files. The nice thing about intermediate files is that it writes to disk and you don't have to store in memory. Okay. The thing we're about to learn stores in memory, which means it's friggin' huge, it's something to go wrong.
Yes.
Well, quite pretty efficient.
Yeah, well, again, for a lot of things, they're just reading through line by line and adding it to the file, and so it's...
Do it either way is the real answer. Yeah.
It's all standard by line, so the memory.
The only issue with doing it this way is sort of like, what if you were doing a wet lab experiment, and at every step you save the leftovers? You end up with a freezer full of crap.
Yes. And there are times when that's good and times when that's bad. Sometimes, when you're first, I'll ask you, for everybody who's done a wet lab experiment, when you first do an experiment, how many of your intermediates do you save? If your answer isn't every single one of them, then you're probably lying to me, because, you test every single one of your intermediates if something goes wrong. And so when you're first writing a script, a lot of the times it's really helpful to save every intermediate, check those contents, and see that they're doing what you think they're doing, right? So yeah, it depends is the answer, and we will learn a more efficient way in about 5 minutes. So, okay. So before we get to pipes, actually, we're going to talk a little bit more about saving output. So I've got my list here, and it's got ball, Linux, Unix. What if I wanted to add some values to this list, but I didn't want to use Vim? I could append some values to this by printing out something else. So we're going to do my second list. Whoops. I did lit, but whatever. Litty, lit, lightning, lighting. All right. Got some great values here. Oh, WQ. So, got my list here. Oh. So I could cat my second list, lit, of course. It's going to do that. And then I could add in a second greater than sign for cat and append all of those values that I'm printing to the other file. So what happens if I look at my list now? Well, we've added a whole bunch of stuff to the end. That's pretty lit. That's pretty amazing right there. All right. There is another way to do what I just did. Anybody want to take a stab? How could we do that without appending? Type it in with Vim. No. This is raw. This is important raw data right here. We don't want to manipulate this. Too bad. If only cat stands for concatenate, yes. We could do my list and my second list. Now, of course, I've already edited my list here, so it's going to have the entries here. But this will print out both of those values at once, and then we could just save them into my litty list. So, there are lots of ways to skin the Linux cat. So, womp womp. All right. So now we have done a lot of manipulation. We have a lot of intermediate files, and as Mary and Robin have alluded to, there are ways that you can actually just do it all in one stretch, which is often the better way to do things. Okay? So I mentioned before that everything is printing to standard out, right? We can actually pipe the output of certain commands into the input of other commands. So for example, we did cat. This just prints everything on the screen. We could do cat and then add a vertical line, which is just the key right above your enter. So it's shift and that key to get that vertical line. And this is saying I want to pipe my output from this command into the input for the second command. So we could do cat mylist sort -n. And you notice that with sort -n, usually I had to give it a target file. I don't anymore because it's taking the output of my previous command as its input. So now it's going to sort -n all of the stuff that I outputted from the previous command. And so now it's going to sort that file, even though I didn't specify that output because it's taking that output from the cat command. All right, so let's go back to our actual fun data here. We've got our chromosome1.bed. We've got this big file. So we can print the output to the screen. How do we get specific columns out of that output? What's the command?
There you go, somebody got it.
Yep. So that's sort. How do we cut the columns? Cut dash F1, 2, 3. So now we can cut those first 3 columns. So we are printing everything in that file and then cutting the first 3 columns out. There you go. All right, now we want to sort that output. How do we do that? Somebody had sort in their heads before, so sort dash K 1, 1, dash K 2, 2, N. Now that's the sorted output of that string of commands, all right? What if we wanted to save this long list of commands that we've done to a new file? Greater than, so we can do greater than to piped bed file stuff.bed. And now we can see that we have a new file that is not only the sorted stuff, but also has only those first 3 columns because we've input that cut command in there as well. All right. As a reminder, you can scroll up using your arrow keys to get to old commands. So let's add just one more fun thing in here. What if we wanted to fetch a certain patterned value out of that output? Grep, okay. Grep. What's your favorite 3-digit number? 1, 2, 3. All right, let's see if there's any 1, 2, 3s in here. Oh, no 1, 2, 3s. Sorry, not your lucky day. We'll do 209 because I know that there's a 209 in there. Oh, and that's because I'm saving it. Whoops. There might have been a 1, 2, 3 actually. Let's check. Nope. There we go. So we have found the one line in there that actually has the value 209. Sorry, 1, 2, 3 was not in there. So as you can see, you can be very, very efficient by just stringing together all of these commands. You'll also notice that that line gets really, really, really long. So make sure that you are where you think you are in your command chain. Check the inputs and outputs of all of your commands. Make sure you know what they do. Make sure you're not losing data somewhere along the way. And this is where,
As you say, her comment comes in here.
Yes, this is where looking at intermediates is good practice. And so, as I said, this is very stylistic. You can kind of choose which way you want to create your scripts. But my first thing that I usually do when I'm either troubleshooting or just originally writing is I do the commands individually, look at their output, and then put the pipe together, okay?
And one smart way to do that is do a header on your input file into a mini input file, build the entire string to work on that mini input file, and then deal with the big set of data.
Yeah, how do we cut just the first 10 lines of our file? Not cut, but how do we print just the first 10 lines of our file? Yeah, there you go. So if you wanted to make a mini version of a file that you could work with, instead of 2 million lines, you could just work with 10 lines, and then it won't take 30 minutes to run your command every time. So
an important thing to remember is Linux does exactly what you told it to do. But very commonly, you will tell it to do something that you don't know you're telling it to do. So you check your intermediate files, Because I don't want to admit how often I've told it to do something, so why did it do that? Oh, I told it to.
Okay. Perfect. So we're going to kind of take it from the top, do a little bit of another dry run here of copying our files, manipulating our files a little bit, and then getting the information out of them that we want. So there is another file in that same directory that you originally copied this tar.gz file from, called srr409 blah, 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 okay? So how do we look at the contents of a directory? ls. So we can first of all just navigate to that directory, public. I've got to take a look here, 2021. As a reminder, if I kind of can't remember the path, I can just hit tab twice, and it's going to give me everything that matches the pattern that I've typed in. I haven't typed anything in here, so it's just going to give me everything. I can go into data files. Again, I don't really remember what I got, so day 2. And then bed files. And if I hit ls, it's going to give me the contents of everything there. So I say, there's my file. That's what I want. So I can, well, I guess we'll use rsync. Good practices. We will find that file. Remember to tab complete so you don't make typos. All right, and we want to copy that file into our bed files directory. So 2 ways to do that. Number 1, what is it? Specify an absolute path. Number 2 is relative path. That sound familiar? Right. So what is the relative path for the directory we're currently in? Just 1 dot. I heard it somewhere over there, so I'm just going ahead with it. All right. So we have now successfully copied our file over. Green sticky note. When we have our copy filed over, please. I'm seeing slightly confused looks. If you have any questions, please feel free to ask them.
What?
Why say
Yeah, if you need a red sticky note, let us know.
Oh, yeah, sure.
I'm not where you are at this point.
Sorry, I'm in bed. I've just been in bed files the whole time, so. Oh, because you didn't specify. Yeah, so that is something that we talked about a little bit, but if you are in a working directory, that is the only directory that Linux has knowledge of at that point. You know, so you can tab complete files in that specific directory, but if you want to search for files in other directories or copy them, you have to specify the path. And so tab complete will only work once you've specified that path. That's, yeah, so. Do you want to? Yeah. Sorry, I think only Ariels are TA right now, so. All right.
Please give us a great signal if you haven't copied over.
We got a couple more, I think. Getting there. No rush, we got plenty of time, so.
So the other nice thing about tab is it prevents typos. Because when you're copying something that long, you're very likely to have a typo. If you ever double tab and get nothing, you already have a typo.
Yeah, I mean, 99% of your errors are you made a typo, so check that first. All right, I think we've got everybody except for, yeah. So we will go ahead and just do the next step. All right, so I've got this file. You'll notice that it has the .gz ending. So what does that mean? Means that this is not, this has been zipped, so it's been compressed. You did learn one command for looking at compressed and archived files. That was tar. All right. I'm not going to be nice to you. I'm going to make you use a second command now. Because as is the case, you're going to constantly run into new commands, and you just have to learn how to use them. So the command we're going to learn how to use is gunzip, kind of spelled like gunzip. I just call it gunzip. I think everybody does. How do we start to learn a command? What's the flag? --help. So we can type in gunzip --help, and it's going to tell us what we need to do. All right, so we need to point it to a file, and it's going to uncompress that file, and this is going to be for these .gz files that you're going to encounter. All right, so how do I uncompress this file? Gunzip, srr, and then we can just tab complete the rest of it. Let's take a look. Did it do what we think it did? Oops. Look at that. We have unzipped that file, so now it is something that we can actually take a look at. All right. Green sticky note once you have copied that file and unzipped it.
So the --help word options and brackets, does that mean?
Yeah, it's supposed to. Like I said, not everybody follows the same format. So they are still optional even though they put that there.
Sometimes as well, again, this is all stylistic based on who wrote it. The options are mandatory, but they have defaults. So, like,
And
yeah.
that would be why it's got a square bracket, is because there is an option that is mandatory, but it has a default, and therefore you don't have to use it.
Yep.
It's funny because it's mandatory, you're not setting it.
Yeah. Very, very silly stuff, but when you go and write your programs, please follow standards. Not unless you tell it to. So.
How would you tell it to? Oh,
Is it minus X?
I don't remember what it is. I'm looking at it here and I don't see the option. Does? Oh yeah, there we go. -C, and then it would write it to standard out, and you would have to save it using that greater than symbol. Look at that. You guys are better than I am now. All right. I think we got one question in the corner there.
just look at L.
Ariel, I think there's one more question up there. All right. Looks like most of us have gotten our file here. Let's print and take a look at this file. So, favorite command, what do we want to use? All right, I heard less this time. Let's do less. All right. So this is a very similar file. This is called a bed graph file. Again, you're going to learn about all of these files next week, but you can see very similarly, it's just a genomic coordinates file, and we can scroll through it with our arrow keys. Take a look. It's quite a bit longer than the other one, as you can see. Let's get out of less by pressing Q. So how, I scrolled through and I just get a sense, oh man, this is kind of a bigger file. How do I check the number of lines for the file? Word count -L, all right. 259 lines, that's amazing. That's definitely not even close to the size that you will be working with. They're going to be quite a bit bigger than that. Okay, so we've taken a look at this file. We can do one more. Let's go ahead and say, what other fun commands can we do here? How about we sort this file? I think it's already sorted, but how would we sort this file? Sort, okay. What else do we need? -K. So similarly for these files, we want to sort on the we know that the first column is a chromosome. We can sort on that one normally. Second column, we want to sort numerically, right? All right. And let's say we don't want to have to print all of those millions of lines out onto our page here. How do we look at just the first 10 lines? Head. So we can pipe the output of sort into head. And we can see that it has sorted beautifully, and we only get the first 10 outputs, or first 10 lines. So now that we've checked the output, we can say, all right, perfect, I want to save this. How do I save? Say it standard out, greater than, and then your favorite file name. So we will call this .sorted.bedgraph. And there we go. All right. Perfect. So, yeah, go ahead and throw a sticky up if you have gotten up to this point with us. Okay, I think we are doing good here. If you are feeling, like I say, if you're falling a little bit behind, don't worry about it. Feel free to ask questions, and also we have office hours. So let's see, I think, yeah, let's go ahead and move on to the very last thing that we're going to talk about today. We're going to go back to Vim, so I hope everybody has, done their Vim tutorials and is not going to get stuck in the endless loop of being in Vim forever. So, all right, so where are we currently? Well, that's PWD. We are in bed files. So to keep our good organization, we don't want to just save everything that we do in one directory. We want to organize ourselves, always good practice. So let's go back out, and we'll take a look. Yes, okay. So if we ls, this is running really slow for some reason. We can see we have moved one directory up. We can see our hierarchy here. So one good thing that I'll mention before we move on to the next is that it's always a good idea to have a README in your project. Just for anybody that goes through your data, they want to know exactly what you are doing and how everything came to be in those files. So we can ls and then just put the output into a README. And you can see, if we do ls again, we now have a README document. So let's go ahead and open up that README with Vim this time. And what do we see? We see a list of those directories that we have there, okay? So now we can enter insert mode. How do we enter insert mode? Very easy. And we can type a very quick description of all of these directories for anybody that's going to come in and look at our very wonderful project here. So audience plant, the most wonderful question ever asked, for example. Bed files, you would write a description for all of these files. I am not going to bore you by writing a description, but I will give you a few seconds just to play around in Vim. So when you have Vim to your heart's content, go ahead and put a green sticky note.
Remember, your computer is a lot like the fridge or freezer in your lab. It will be as organized as you make it. And it will take you just as long to find something if you don't label things well.
Okay. All right, so I think we're looking pretty good here. So how do we exit Vim and save what we've done? Escape and :WQ. That will get us out of Readme and save what we have done. Okay, so we know how to edit things, we know how to manipulate files, we know how to copy files. We can now start to build this into scripts, which is what you're going to be running. And we're only going to do a very cursory overview of scripts today, but this is going to be the main way that you're going to actually interact with your data. Is you're going to be writing commands in a document, basically, and then using that to run through a list of commands, okay? So everybody change your directory into your scripts directory, which you made when Ariella was teaching.
BWB so they know where it should be.
Yep.
Anybody not able to get to their scripts directory?
Okay, so we are going to, we're going to start a new script. We're going to call this my first script.sh. Okay? I guess it's technically your second script. Ooh. My second script.sh. All right? So we already learned yesterday about how these things work, right? So you write a list of commands, and then when you target this with bash, this file with bash, it's just going to read line by line through those commands. And so before, Mary had you assign a variable, a equals 5, whoops, I forgot to enter insert mode, a equals 5, b equals 6, and then echo value of a, echo value of b, for example. And when we save this document and run this document here,
By the way,
it's just going to do those commands in order, right?
yesterday we ran it with sh bash or sh is the same thing. They're just two different ways.
Oh, yeah, yeah. Okay, so hopefully everybody is familiar with how these work. Now, if you wanted to do any of the commands that we had learned about earlier, but you wanted to keep sort of a documented path of what you had done, then you could write all of that into a script, right? So let's go into here. We can delete everything that we just did. And now we can go ahead and assign our variables just the same as we did. But instead of using numbers, we're going to use files, right? So we can say bed file equals, and now we need to go and find the path, right? So I don't know the path off the top of my head, but I can always take a look by exiting Vim and going into bed files, and we will use our SRR. Well, actually, let's use our old friend, ENCFF050. DNG, oh please. Okay, so if we just ls, we can find that path. One of the things you can do is just copy this. So literally just Control-C on your keyboard. And then you can go back into Vim and use this as the path. Oh, it does not like copy on Windows. I was in insert mode. I don't think it just copied it to the keyboard. Oh, yeah. Excellent. There we go. Hey, no, don't worry about it. Windows works great with PC. So we can save the variable bed file as the path to our target file, right? Now, we...
Is that a relative path or an absolute path? Thank you.
It is relative right now.
Better to write them one versus the other. Like, you're never going to move that script out of the script directory.
Yeah, so you will always be safer if you do an absolute path. Specifically for what you mentioned, you may think I'm never going to move this file, but inevitably scripts move, scripts change, and everything like that. So, sometimes it's okay, especially if you're saving like a temporary file to a location that you know where you're going to be saving it to, then you can use a relative path just fine. But,
The positive about relative paths you won't run into for a while, but let's say that this is in his user directory, and he copies this somewhere so I can put it in my user directory. If it had an absolute path, I would have to go through and change every position that has his username. If he's got a relative path, I don't.
Yep, exactly.
So there are positive and negatives to using absolute and relative paths. And you have to think about, am I ever going to transfer this to someone else in my lab? And then you would want to use relative paths because then it still works even though. Like he said though, I like absolute paths because then I don't lose things.
Yeah. There's also things like if you're sharing a directory with somebody, obviously you want that to be an absolute path because that directory is shared between the two of you and you want to specify exactly where it's at. So, the relative path to that directory for you might be different than the relative path for them, right? So it depends, as with a lot of things. Any more questions about that? Okay, so we've written down we want to assign this variable bed file, right? If we run this script right now, it's not going to do anything but assign a variable, okay? So how do we print this variable? Yep, so we could echo bed file, okay? Let's go ahead and exit Vim and just try that script out. What does it do? Just prints that path for us because we just told it to echo that path, okay? Now, that prints out the variable, but what if we wanted to print out the file that that variable is referring to? So we could use the command cat and then call the variable bed file. So now what do you think this is going to do? When we run this, it's going to look at that variable and it's going to insert the value of that variable as the target file for cat. So it's just going to print the value of that file now. Okay, this is the exact same as if you had typed in the path for that file for cat, right? But obviously, it's quite a bit easier to just type a variable that you've named rather than typing out this big long path every single time. So variables can be a great way to clean up your scripts and make sure that you're using the exact same path every time. They help with typos as well, basically. All right, green sticky note when you've gotten to this point. Red sticky note if you need help, always, yes. Oh, we got one over there, yep. Sorry, is this unreadable? Okay. I think color scheme, is Elf Lord a good one? I seem to remember Elf Lord being a good one. Is that better?
I like Elf Lord.
Yeah.
Another advanced dim command, color scheme. Red sticky note if you need help.
Okay. We'll go ahead and go to the next part here. So before, we had set up a pipe to do a whole bunch of things for us. So we can do that in our scripts as well, and it's the exact same thing as if you were just doing it on the command line. Remember that a script is nothing more than a list of things that are going to go one by one into the command line, okay? So we could cat bed file sort dash n 1 comma 1 not n k 1 comma 1 k 2 comma 2 n, and then we could save that to a file name. So we'll say this is ANSI whoops, 050dng.chromosome1.bed. When I save this file, where is it going to go? Which directory are we going to have this file end up in? Yeah, it's our current working directory, right? We haven't specified that it should go into bed files. Okay? Remember that wherever you're currently working is where the files are going to go unless you specify a path, okay? So we can specify bed files, either relatively or absolutely, by doing that. And we will add sorted.bed for this. All right. So now when we run this script, save, I don't know why it's heading so slow on here. But, oh, that might be it. Yeah, that makes sense. Yep. So now when we run that script, it's going to do all of those commands, and it's going to save our file. So we can check whether that worked by looking at that file that we just saved. DNG chromosome1 sorted.bed. And voila, we have printed this sorted path.
Just go back into your my.
Sure. I can absolutely try. That is the awful color scheme again. I know, Elf Lord. What a great name, too. I know, right? Green sticky notes when you have gotten to this point, red sticky notes if you need help. Yeah. Yeah, so that's telling it the column to sort and which key to use to sort that column. So I don't think so, no. I have never tried it, have you?
Like I said, there's always 10 ways to do everything.
Yeah. Okay. Got a couple of holdovers. I'll wait just a bit.
Yeah, you can't have complete inside of files. That may be confusing some of you guys.
Yes, I forgot to mention.
Inside of a file, you cannot have that.
Yeah, Vim has no knowledge of the outside world, unfortunately. So. I think actually you can access a bash terminal inside of Vim, though, right?
You can, and there's also inside it, but that's outside the scope.
Yeah. So I never use that myself either, but it's probably good for when you actually know what you're doing. So
It's a little,
a little bit less tedious than going in and out of Vim. So. Yeah. This is once again falling off the side of the screen. Is that readable back there? Is there just a blank color scheme? Is there like a white or something? Nope.
you can change your VMR status of the color scheme permanently.
Yeah, I don't know if we want to mention that or not.
Is there a done color?
Yeah. Dark blue. Evening, morning, Murphy, Pablo, Peach Puff. Zellner? No, that's even worse. Yeah, that's way worse. Oh, perfect, okay.
These are just,
Yeah.
it's just impossible to track.
Yeah, sorry about that. These projectors.
Those projectors, it's
Yeah, they're starting to burn out a little bit. So.
Where am I?
Oh, yeah, sorry. The
Oh, yeah.
Of course, this is aerial.
well, that's fine. Excellent. That's much better. Yep. Hopefully that's a little bit more readable. Okay. That's the only way anybody knows where anything is. It's PWD and LS. So. Huh? I'm not touching tree. That was in the document. I was like, I don't want to look at this. Fun fact: tree is what some like scammers use to try and simulate a scam. Because if you tree from the whole directory, it's just going to print everything and look really, really scary. So.
So most of the problems we're running into is typos. So one of my tips, propose this.
Sure.
You're in the script structure right now, so you can LS that path. So LS with the whole path of the 2 file.
Yeah, I will.
You gotta just write
Oh, I was gonna. Yeah, I can do relative here. So.
Because then, if you LS it, the nice thing is it will be on your screen. You have tab split in it, and you just copy it and paste it to your file. Then you won't have to type it.
You ever do real path?
What?
Real path. So here, like if you do real path, it's with LS on the directory.
Oh.
Oh, really?
It'll just give you the full path. Very nice. I like that.
This is nice, I didn't know about real path.
Hey, look at that. That is nice. Can I guess I could also, if I wanted to be real stupid, just ls and then put that into real path, like pipe it into real path, and it would print out the real path of everything.
Generally, it's not a good idea to parse LS output.
Okay. No, fair point, but like.
But, yeah, I mean, the way I would do that is to use like find dot and then type it.
Right, yeah.
Or you might have to use an
Yeah.
So submit your script, if you have submitted your script and you'll actually, it is done what you think it's supposed to do. Oh, you can open it again.
Yeah.
Sorry,
No, we're
for technical
good.
people, I was giving them a tip.
Yeah. Oh, you mean the script?
Yeah, open the script.
Yeah. Where am I? Yep.
So if you've submitted it, then what should be true? How do you know that it works? That's right. If you go to your bed files directory, you should now have that .sorted.bed file. If it exists, please put a green sticky note up. So if you have .sorted, or you have ENCFF050 at the end, chromosome1.sorted.net, give us a green sticky note. If you do not have that file, take your green sticky note down, so we know who has the file. And if you need help, red sticky note will take.
Yeah, we got a couple of holdovers, so I think they're being helped already. So.
Green sticky note if you've got the sorted bed file, otherwise red. So I've got an article, I can put it on our additional links. And the article claims that if you do anything on the head node, not inside a script, that it is research misconduct. I'm not sure I believe that, but that is what the article claims. Because they say you can't track what you did, and therefore it's research misconduct.
Oh, yikes.
I do say most everything I do in a script. I do not literally do on head node. What? Can you explain that? So right now you wrote a script and it sorted the bed file. You could have done that on command line, like we did earlier, right? The problem is, in research, you are supposed to be able to track every step you completed. So if you sort on the command line, and then 6 months later you go to write the paper, and you don't put in there how you sorted, or you can't remember the exact command how you sorted, that is considered bad research practice, because you cannot reproduce what you did. Whereas if you put it in your script, now you can just open your script back up and see exactly what you did. Writing your methods paper becomes easy, or methods section of the paper becomes easy. So I don't hardly do anything with files on the command line, other than looking at them like head more or less. If I'm going to manipulate, if I'm going to make a file, I do it inside a script, because then I've got a record of how I did it. Yes, yes, exactly.
You know, we should
the
make that part of the
README
course.
What?
So we should make that part of the course at some
Yeah.
point, best practices.
So the README files are part of the best practices. Every directory should have a README. It should say what is in this directory and where did you get it and when did you get it. The other best practices is every time you manipulate a file, you make a script. And somewhere you have a list, and maybe it's in the README, often mine is, that says this script was run, and then this script was run, and then this script was run.
Yeah.
Because then you can follow exactly what you did.
We'll also.
You can skip that if you want, but you will hate yourself in 6 months when you're going to write the paper.
A quick teaser for tomorrow as well. I think Zach is going to go over a little bit about constructing those pipelines, and you can have the pipeline save basically a copy of what has happened as a log, which, you know, a lot of programs will already do that for you. So that kind of comes baked in with a lot of bioinformatic tools. But, you know, always check. Huh? What's going on?
I did not lock down what I needed to. Somebody moved the file.
Oh, is that what happened?
I think we'll fix that. Somebody used move instead of copy, and I haven't had it locked down.
I was wondering.
I
was like, oh man, I wonder if that file still exists.
And actually, I think it'll probably fix it.
Yeah. All right. Is that the issue that we're having with those two back there then, I assume? All right.
Now we'll lock this properly. Clearly I should have.
I could probably also copy over from here. Oh, yeah. All right. That should help those people like that. All right, if you are still struggling a little bit, like I said, just put a red sticky note up. We're going to move on and just do the last part. And yeah, if after this you're still having trouble navigating the command line, remember, office hours are always open, and we will go through this. So, all right, so we have hopefully at this point gotten our file. We've been able to do this sorted output. Now we have a nice log of what we've done because we've written it in a script. One more thing that I want to mention as well. Why is this not? That was very strange. So let's, for example, say that we want to save the output of a file, but we don't want to have to type this path every single time we do something. We can save another variable called output. Files, cff 050 dng.chromosome1.new.sorted.bed. So even though this file doesn't exist, you can still save this string as a variable and use that to call as the output for this particular function, right? So if we now say, cat this bed file, use it as the input for sort, and then save it into the output variable, it's going to look at this output variable and use that as the path to save the file, okay? So that way you don't have to type out the entire path to save it. Even though, again, this doesn't actually exist yet. So everything that you're writing in Vim, these are just characters. These are just variables. They're not looking for the file or doing any checks for you or anything at this point. All of that happens when you actually do the command itself, okay? So this is, again, this is a very good way to just sort of clean up your script. If you have lots of target files, lots of output files, you can write variables for them to make it a little bit easier to read. So now we can see that this command is very nice and easy. We know we're going to be printing a bed file to our standard out, sorting it, and saving it to some output variable. And we can check what those variables are by scrolling through our script, okay? One other thing I want to mention, because again, this is going to be a really good way of cleaning up your script, is you can kind of combine variables because again, in Vim and in the bash script, it's not actually going to be looking for anything but the value that you've given the variable. It's not checking the path or anything for you unless you ask it to. So if we had a directory that we wanted to work in, we could call it bed directory, for example. We could set that path, bed files, and then we could call other variables using that path. So we can say bed directory. We can put it in these little squigglies just to make it a little bit easier to read.
Actually, why do you have to have a squiggly there?
Oh yeah, I guess in this case we do.
So
We got it. Yes, because otherwise it's going to look at the whole string.
after the equal sign, it will make everything as part of that variable. So if he had no squigglies and no slash, because the slash is going to break it too.
Yep.
But no squigglies and no slash, it would think that the $ bed directory ENCFFF was what's all the variable name. That whole thing was the variable name. So go ahead and delete the squigglies and the slash in bed files so that you see what I'm talking about.
Yeah, so if you were to do
That,
this,
it thinks that whole thing's the variable name, which it's not, right? So you put the squigglies around bed files and say this part of it is the variable name.
okay. So we're going
So it's correct.
we'll go ahead and fix this now. And so now bed directory is pointing to the bed files directory. Bed file is asking, okay, what's the variable bed directory? Oh, it's bed files. Still need a slash there. And then the bed file is going to be this enc ff, blah, blah, blah. We can do the exact same thing for output now. Call bed directory. And then have this new output. And then all of this should work as expected when we actually run the script using bash. So we can check.
So why do you think there's a benefit to defining the input and output directories along with the input and output files? Portability, that's right. So if I run it and then I want to hand the script to my friend, their new directory is probably not the same as my directory, right? So they can just change the directory name without having to change everything else, and it will rerun in the new place.
Also great if you're adding to your pipeline some more things. You don't have to keep on pointing to new directories every time you write a new command. You can just use the variable. So.
And you can tie as many of these together as you want. So I, for instance, will often have a root directory in which the entire project is in, and then a subdirectory for bed files, and a subdirectory for BAM files, and a subdirectory for gram files. And so you can literally tie all of those together over and over again. So you define the root directory, and then the BAM directory is the root directory plus something, and the bed directory is the root directory plus something. Suddenly, you've got an entire directory structure and defined in 3 or 4 lines. And if someone wants to rerun my analysis, all I've got to do is give them the input files and that run script, and they can redo it.
Yeah. So that should hopefully give you a little taste of the kind of scripting that we're going to be doing. As I mentioned, scripts are great because you can build the whole pipeline in the script and rerun it as many times as you want and play with the output. Our little pipeline that we have here is pretty tiny, but it's going to get much, much longer, which Zach is going to teach you tomorrow. So yes, he's smiling deviously for it. All right. So that ends sort of the, oh yeah, who had a question?
Can we just bring up the script?
Yeah, sure.
Maybe you can just leave it out.
Sure, what's up? Yeah, you can. Yeah, that's a little bit more advanced. Although, yeah, if you want to come to office hours, I can show you how to do that. There's an easy way and a hard way. So.
It's really fun to do that too, because you can build a script that say does mapping, we'll do on Friday, or sorry, do Thursday, and then you can just feed it each of the files one at a time.
Yep.
And it will map that one and then move to the next one.
Yeah. There's lots of advanced things that you can do. You know, this is a basic programming language as well, so for statements, if statements are all built into this. So.
And if you wanted to learn how to put a bash in the script, or sorry, I gave it away. If you wanted to learn how to put a for loop in the script, what would you Google?
For loop.
For loops.
Bash.
Yep. So.
If then statement, bash.
We're not going to go over that today. I don't know, Zach, you might be touching on something like that tomorrow, maybe not? Not really? Okay, yeah. So advanced usage only. If you want to learn about that, that's on your own time or office hours.
The problem is you can create an infinite loop and kill things.
Yeah, fair point. I guess we don't want to point anybody in that direction. Yeah. Yes. All right. Any other questions about this?
Yes, I have accidentally done that. I have accidentally almost killed the giant supercomputer by nesting things in a way that I didn't need to, and having a script make more scripts until I pulled up the entire queue. Yeah, oops.
Yeah, I tried to move too many files at once, and it nearly crashed as well. So I got an angry message from IT.
They're really awesome, our IT is, but you know, you can make them angry by trying to kill the supercomputer on accident.
All right, everybody clear on this and everything that we've talked about today? I understand it's quite a lot, but...
Can you go to the website to show them their homework?
Oh, yes, okay. Do you already have that pulled up by chance?
It should already be on there, I think. Go to
DnA Lab?
DnA Lab, there you go.
Perfect, okay. So everything that we talked about today, along with some very helpful slides, this, I was going to say, I don't think that this has been refreshed in a little while. There we go. Everything we talked about today, some cheat sheets, some walkthroughs, along with all the videos are here, along with some homework that's going to walk through some basics of what we did today and test your knowledge. So make sure that you can complete the homework comfortably for coming into class tomorrow, because we're going to be building off of everything that we learned today. So, all right. Any other questions? Any other thoughts? I do have some closing tips for navigating Bash if you are interested. So I can go through those just really quick. These are literally just easy ways to navigate, excuse me, easy extra ways to navigate things. So let's say you've typed out a whole bunch of stuff and you want to go to the beginning of the line. You can press Control A, it'll move your cursor to the beginning of the line. Control E moves it to the end of the line. We've already mentioned tab complete, and you can scroll through your history with up and down. If you wanted to search your history, you could do Control R, and then type a command that you had done in the past, so vim. It'll pull up all the commands that you've done with that, and then you can pull it up pretty easily. There's lots of little hotkeys and tips and tricks, and I've put them in the worksheet as well as on the website, and if you're ever curious, you can just Google more tips and tricks. So yeah, what's up?
Is there a way to like save everything I've done by terminal?
Yes, you can, yeah. So if you type the word history, it's going to show you all of the commands that you've done up until this point. Yes, it does. It will clear your history. So. So far as I know, everything that you've done in that session. So how do we save the output of history?
Well, I mean, like, the output of each one of these.
Oh, the output of each of the commands. I was going to say, technically you can just load up history and just run it like a script if you really wanted to do that. I wouldn't suggest doing that, but you could. But yeah.
How do you save history in case you want to save it?
Greater than, history greater than, and then history.txt or something, yeah. So, all right. Awesome. If there are no more questions, I think that we are done for the day.
And write that number down because it changed. Don't forget to write that number down. You can't do your homework without that number. Oh, that's a good point. Lynn said, oh, by the way, for homework.
Yes, yes.
Lynn said she was going to post a.
There's a key
She posted it.
for the homework, for the FastQC homework from yesterday.
No, there is actually a built-in file name.
What does it do?
So what you need to do is you do Control X, Control S, and it'll do file name completion from whatever it's top.
Oh, no, I need that.
That's awesome.
That,
Control X, Control F, that is so good to know.
It's incredibly inaccessible.
Yeah.
Unless you know it in advance.
Yeah, there are lots of things, like, I guess we could have gone over wildcards, and I forgot to tell them how to remove files. Yeah, so, yeah, removing wildcards, you're going to have to touch on that. I completely spaced that one.
I need to add some stuff.
like a word file with like different.
Yeah. So.
Although you can't Google symbols of Linux, there's great pictures, like all the symbols.
I love it. It has like dictionary completion,
We go over basically.
It's by next week, you need to remember. Next week, we're gonna be live.
Tomorrow, again, it's bad.
That's right.
We're just hanging out for now until office hours are at 1, right?
Yeah, I'll start her at 1 meeting. Generally, no one shows up. If someone shows up, it's one or two people the whole time. You just work.
Yeah, no problem. Oh, nothing's wrong with it. It's a foster. It's just a checkup. She's got like priorities, so she's they got Abby needs to do some work. It's like an animal kitten, but all.
The other thing we should talk about is talk about technical analysis. Yeah. Which may or may not.
We will not touch on the screen, but
No, don't touch screen. That's a little bit.
That's sometimes. I'm like, oh.
It's amazing to me how many useful tools there are that you don't learn until you're working on it. Like screen.
yeah, the learning curve really never stops.
No.
I discovered new like
Command that you're like, oh, that's freaking cool.
command feature.
And some of them still, some of them don't.
Real power is like using like Hotkeys all the time. It's just like I need it to full package file. Like parsing.
There and somewhere near there. I just dropped my
So it's good.
Yes, yes, we do.
Oh.
Let's figure out what's wrong.
Yeah, that was really dumb. I guess you have your, I'm going to take off and come back for office hours, so, yeah.
If it works on mine, it should work on yours. I don't
Yeah,
know why
well,
it's
I mean, it doesn't
one
need to work
flaky.
on mine anymore.
That's true,
My
you're
day is
done.
done,
True,
so,
just his.
yeah.
Okay, so
very
here's
strange.
his.
Good job, Sam. Oh, thanks.
Yeah, I enjoyed this.
It's always fun. Teaching Unix is fun.
I think so.
Okay, Harry, I was gonna say, did Ariel disappear and leave his laptop?
No, he's still around. He's
This
just
is
talking.
yours.
Yep.
This is the
Labs.
labs.
And why are we not working?
Do you want me to go upstairs and get the other one?
Because if we have the labs in this one, it can't be
This
the,
is just VGA.
oh.
I have a question. I did not get to look at the last script. I don't know what it was.
And it worked, but now you have to actually do something. When you tried to do the slides, the things fell apart before. Nope, gone. Okay,
What's going on?
I don't know. I'm gonna go get the other. Can I?
Adapter, just in case that's it.
I'll probably miss this screen. I'm gonna go sit out in some place.
Yeah. Ooh, new place. Very nice. But you don't have to help them every day. It's whoever is in charge of that day. So we have to be there tomorrow. Uh-huh. Yeah. Tomorrow's the one that kills him.
That's why I want to get familiarized beforehand.
Yeah, I think that's what I'm wondering.
We're still trying to figure out why this isn't working.
Because this one, so here's the
Well, Graham, how was it today?
second script.
Rob went upstairs to see if another adapter.
It's printing your variables in main, yeah.
But I'm supposed to get.
Yeah, I just,
Whatever it is, right? This didn't come out.
Yeah, no, you're submitting your original.
Oh, so I have to.
And you're sorted. You're viewed. There you go. Yeah.
Okay, good. Okay. Cool. So now I guess I could understand this.
Everyone does not know what was, or the last thing was different.
Oh, girlfriend.
What?
Read your first two lines. Wait, where we go? Yeah.
Yeah.
Oh, so that's extra D. Provide it through. Okay. I'll do if you can help her. Yeah.
Well, I had. It was doing that before. It's like. No, I just, I have a second.
Oh.
This.
The directory. Oh, no, no, main directory.
Yes. Really well.
Too well. This is,
Yeah. Working now?
Found something online that says there's a little button called Detect Displays, which I already had displays up, so it seems weird that it would do that. But, and it's something about it not correctly detecting displays.
I want to try this.
Okay. No. So what it said was that it's the display resolution that is the problem.
Okay.
Or did it say to fix it is the question. Let's see here.
I'm going to stick this back then. So why did it work yesterday?
I don't know.
Why do I say cat?
your script